He opens his eyes to a sky that appears simple and finds it layered like a seashell, ring within ring, time folded inside time. The dark is not empty. It is crowded with travelers that left their homes before the first stories were told. He listens with his eyes and hears a slow pulse that is the speed of light itself, a steady metronome that turns distance into memory. The word edge arrives in his mind with the weight of cliffs and endings, but the heavens do not offer a ledge to stand upon or a fence to grip. Instead, they give him a boundary that belongs to perspective, a limit drawn not on the fabric of space, but on the map of what can reach him. He feels the surprise arrive quietly. The edge is not out there like a ridge on a horizon. It lives in the relationship between the traveler and the message, between the present and the long journey that light must make to introduce the past to the now. He watches constellations pretend to be animals and heroes while knowing they are only temporary alignments, lights that share his gaze but not each other. Their arrangement is an accident of vantage. The real structure resides in depths so great that language has to become patient to speak of them. He imagines a kind of shoreline that surrounds him in every direction, not circular like the sea, but historical like a diary that ends where the pages run out. Beyond that shore, events carry on without the possibility of conversation. He finds this both unsettling and tender, as if the cosmos were granting privacy to distant moments that will never learn his name. An edge that respects silence feels different from an edge that forbids crossing. It turns the night into a cathedral where quiet is not absence but architecture. He thinks of light as a courier with a fragile satchel. Every photon must cross a country whose roads are lengthening as it runs. The courier never speeds beyond its limit, yet the distance behind it grows, and the destination shifts beneath expanding ground. Still, the courier persists, holding its course with monastic devotion. When it finally meets an eye, the meeting is the last chapter of a travelogue that took longer than civilizations. He feels the scale settle on him like a cloak of cold air. No edge is a line that can be walked to. It is a condition that chooses what can arrive at all. He finds himself grateful for the honesty of that condition. The universe tells him what it is willing to share and what it must keep remote, and in that truth his curiosity learns respect. A shooting star scars the atmosphere and vanishes in a breath. The briefness clarifies something he once resisted. Endings in the world of weather and life are sudden and precise. A candle guttering, a wave collapsing, a drumbeat ceasing. The sky above replaces sharp endings with gradients so long they feel like eternity in slow motion. He lets his thoughts pass over the idea that the edge is a gradient too, a change in reach rather than a final door. If he could look farther, he would see earlier. If he could wait longer, he would welcome fainter guests. Time and patience become instruments that extend sight without moving a step. He accepts that stillness can be a form of travel when the vehicle is light itself. He pictures a child holding a lantern in fog. The lantern reveals only a circle of visibility that moves with the child. Outside the circle, the world continues, indifferent to the small island of light. He recognizes himself as that child, and the observable universe as the shimmering circle. The fog is not obstruction but distance compounded by the rule that nothing carries news faster than light can run. He does not resent the fog, it sets the stage. Within the circle, stories can be told, measurements can be trusted, and history arrives with signatures that can be checked. Outside the circle, mystery is preserved with dignity. The balance feels deliberate, as if the cosmos had chosen a speed that nourishes awe. He wonders what sort of geometry can host a boundary that moves with the observer and never forms a rim to touch. Straight lines are not truly straight when space itself can curve. Parallel paths meet at great scales. Angles keep promises that local intuition cannot predict. He takes comfort in the possibility that the universe can be finite in age, yet without a sharp edge in shape, like the surface of a sphere that offers no corner to hit and still ends in the sense that walking long enough returns a traveler to familiar ground. Whether space is ultimately curved like that or flatter than chalk on a board, the lesson endures. Edgelessness can coexist with limits on what can be reached. The idea feels like a poem that keeps repeating a refrain without ever exhausting its meaning. A wind sifts through the trees, and he imagines it as a metaphor for cosmic expansion. Leaves do not race past each other. The tree itself breathes, so too with galaxies. They are not always flying like bullets. The fabric that carries them stretches, and the stretch can outrun light without breaking the law that binds motion inside the fabric. The distinction is delicate and satisfying. It allows distant realms to drift out of communicable reach while preserving the integrity of cause and effect where local physics holds court. He lets this realization settle because it softens the anxiety he once attached to the phrase faster than light. Not all speeds belong to the same category. Not all distances are distances in the everyday sense. He becomes aware of a glow that no human eye can see unaided. It is everywhere, a thermal whisper that descends from a time when the universe was so hot that air as he knows it could not exist. This glow is not a decoration thrown across the dark. It is a message that the entire room of the cosmos once held a single temperature like a held breath. The message does not reveal a cliff. It reveals a transition. A fire thinned to transparency. Particles stopped scattering light like fog and began to let photons travel freely. If an edge must be imagined, he imagines it as this transformation, not a barrier one could knock upon, but a soft threshold that turned the universe from opaque to clear. He traces with his mind the outline of a cone whose tip touches him and whose sides run into the past. Every point on the cone is a moment when an event launched light that finally arrives now. The shape feels more intimate than a map. It is a biography of visibility. He feels a hush in the thought that the cone will always be incomplete because new moments occur and more distant regions slide beyond communication. The hush is not loss. It is a rhythm that keeps curiosity honest. There will always be more than any instrument can receive. There will always be a remainder. And in that remainder, wonder survives like a flame shielded by cupped hands. He measures his breath and imagines a clock that ticks with the universe's own cadence. 1 second per second is an unremarkable rate until he considers what it means at cosmological scale. Each tick admits new arrivals from slightly farther away. Each tick also watches the far frontier recede into a silence that cannot be broken. Progress and retreat happen together. The paradox feels like a tide that comes in and goes out at once. He decides that equilibrium of this kind is not a compromise, but a signature of a reality too generous to be simple. He lowers his focus to the ground, not to leave the sky, but to collect himself. Stones carry a memory of pressure. Rivers remember the contours of the valleys they carved. Everything nearby is a ledger of forces. The heavens are a ledger too, but written in running light and in the pauses between ripples. The scale can intimidate, but it can also soothe. A limit on what arrives spares him from pretending to be omniscient. It grants him the pleasure of learning as a path rather than a possession. The edge becomes a companion that walks beside him, setting pace and tone, suggesting patience as a form of reverence. He closes his eyes for a moment and sees the darkness behind his eyelids blossom with afterimages. When he opens them again, the stars look slightly brighter because his pupils have widened. The change is small, and yet it feels symbolic. Adaptation is a quiet power. The instruments humans build are simply extensions of this widening. Telescopes, detectors, algorithms that tease out faint signals from harsh noise. Every improvement pushes the circle a little farther, not by moving closer to an external wall, but by deepening the reach of reception. He admires the elegance of that approach. Progress becomes a craft of listening better rather than walking farther. He senses a humility that does not diminish dignity. The universe does not trim itself to fit his expectations. He must grow to meet what it offers. Growth here is not conquest. It is attention refined, models improved, questions sharpened. The edge reveals a truth about the act of knowing. Knowledge is not a collection of trophies taken from a defeated landscape. It is a relationship with a terrain that keeps unfolding as one learns how to see. He breathes in and allows the cool of the night to settle the thought into stillness. He lifts his gaze once more and feels the surprise return with a softer texture. The most striking feature is not that he cannot travel to the rim. It is that the absence of a rim grants the night a hospitality he had not expected. He is invited to inhabit a present that is stitched to the past by photons, to be part of a conversation that spans more than any lifetime can hold, to accept that the gentlest limits can teach the deepest lessons. The edge becomes a teacher. Its lesson is patience. Its lesson is scale. Its lesson is that mystery can be kind. He learns that the first instruments were eyes, and that curiosity sharpened them long before glass entered the story. On desert floors and island peaks, watchers marked risings and settings with stones that cast obedient shadows. Horizons were calendars. The edge of the world felt local because oceans swallowed ships and mountains bit the sky with hard geometry. Yet even then, a subtler insight waited in the patient habit of watching. Stars kept appointments with such precision that time itself could be read from their gatherings. A boundary made of order began to suggest itself. If the heavens behaved like a clock, perhaps distance and delay were the teeth of that gear. He follows a thread to a scholar in Cordoba, who catalogued stars with such care that the sky became a ledger open to improvement. He pauses with a mathematician in Samarkand, whose sextants mapped angles with a hunger for exactness. He stands near an observatory in Denmark, where nightly measurements wore grooves into routine, as if the Earth itself were a mechanism that invited calibration. Those efforts did not place a strict edge in view, but they trained minds to believe that the universe could be interrogated with numbers. A boundary in knowledge began to look less like a superstition and more like a limit that could be mapped. He enters a Florentine workshop where lenses are ground thin and a tube is lifted toward the moon. The instrument enlarges craters and disobeys the old idea that celestial bodies must be perfect. Roughness appears in the heavens. Moons circle Jupiter, phases grace Venus. Saturn carries a strangeness that will later be named a ring. The message is not merely that the sky has detail, the message is that detail grows with attention and that new light can be gathered by design. A hand-built device has widened the circle. The idea of an edge shifts slightly. If sight can be extended, the border of the knowable must not be fixed like a wall. It behaves like a coastline that reveals coves when the tide is low and hides them when it rises. He listens to a French astronomer notice a delay in the dance of Jupiter and its moons. Eclipses arrive late when the planet is far and early when it is near. The conclusion lands softly but changes everything. Light has a finite speed. It is not an instantaneous courier. It is a pilgrim whose travel time can be measured. A Dutch observer notices that stars shift by a fraction when Earth moves, an aberration that makes perfect sense if light hurries rather than teleports. Decades later, clever experiments with turning mirrors and toothed wheels capture a value for the speed itself. The number is large enough to humble any traveler and small enough to give time a voice in all measurements. A new horizon takes shape. Distance is now married to delay. The farther the event, the older the news. He meets a woman at a desk, surrounded by photographic plates, where stars pinch the emulsion as pinpricks of silver. On those plates, a certain class of star brightens and dims with a rhythm that correlates with true luminosity. By reading the tempo, she turns flicker into yardstick. The method will teach astronomers to compare what a star should look like with what it does look like, and the difference will become distance. A ladder of inference rises from the emulsion. Nearby clusters yield to farther galaxies. The sky becomes a room with scalable architecture, rather than a dome painted at one depth. The edge pulls away again, not because it moved, but because measuring rods grew. He visits a dark dome in Arizona, where a spectrograph eats starlight and spreads it into stripes crossed by delicate lines. Those fingerprints reveal velocities. A clerk of the heavens discovers that many spirals carry a tint toward the red. The lines have shifted, as if wavelengths themselves had stretched. Motion and expansion enter the vocabulary of cosmic scale. The result does not yet call itself a law, but it whispers of recessions measured in hundreds of kilometers each second. The word universe begins to breathe with a new cadence. Space might not simply hold things, it might participate in their parting. He steps into a debate hosted beneath chandeliers where two astronomers argue whether the great spirals are islands of stars or mere clouds within one grand system. The argument is fierce because scale is a stake driven through the heart of understanding. If the spirals are other cities, then the map of existence must expand beyond old comfort. If they are local weather, then the universe remains a single vast city with curious districts. The ledger of evidence eventually leans toward multiplicity. Distances measured by pulsing stars place some spirals far beyond the reach of any plausible single system. The cosmos extends in tiers. An edge that once crouched near the Milky Way moves outward to a frontier so faint that imagination must stretch to follow. He listens to a paradox voiced in salons and studies. If stars are sprinkled everywhere and have always burned, why is the night not ablaze with their combined light? The darkness itself becomes evidence. Either the universe is not infinite in age, or light has not had enough time to fill the dome, or space is not arranged in the way a naive intuition would require. The night argues for finitude in time or for a structure that spares eyes from constant day. The edge acquires an unexpected marker, not brightness, but darkness, absence as an argument. He looks over the shoulder of a theoretician drawing lines that curve under the weight of mass and energy. The map of space merges with the map of time into a single fabric. Gravity ceases to be a force that reaches out like a hand and becomes a shape that invites motion. In such a world, light follows the curves and cannot outrun the geometry it inhabits. A natural horizon appears around objects that squeeze matter into densities that deny escape. The thought that an edge might be a consequence of shape rather than substance becomes thinkable with clean mathematics. He stands inside a dome that opens like a mechanical iris. Mirrors gather breath from distant galaxies and focus it onto detectors that count individual photons as if they were raindrops. Long exposures accumulate, and the sky reveals that it is not quiet. It is a ferment of formation, collisions, mergers, and jets that spear across silence. Deep imaging turns the void into a crowded plaza. The sense of an edge recedes again, replacing a popular intuition with a subtler rule. The more he looks, the more there is to see, not because the universe is obliging his wish, but because the instruments are finally matched to the story the light has been telling all along. He considers a tool older than glass, patience. Long campaigns of measurement chart the orbital drift of points too faint to impress an untrained eye. From such campaigns, parallaxes emerge. Nearby stars shift against the far tapestry as Earth moves around the Sunday. The geometry is modest but profound. Trigonometry leaves the classroom and steps into the night, turning angles into kilometers without ever touching the places measured. A foundation stone is laid for the ladder of distances that will climb beyond the local neighborhood. The precision born in these small arcs gives later discoveries a platform firm enough to carry the weight of larger claims. He watches clockmakers refine timekeeping and realizes that accurate time underpins every measurement of sky and sea. When time is known, positions become solvable and recurrent events can be predicted with an honesty that persuades even skeptics. The firm stroke of reliable clocks gives astronomers a new backbone. Variations once dismissed as nuisance become signals. Tiny delays, small anomalies, faint flickers, each becomes a message when the rhythm can be trusted. The edge moves not because a boundary has shifted, but because calibration has. He steps into a workshop where photographers bathe glass in chemicals and stop light long enough to store it as evidence. With long exposures, stars too shy for the human eye confess their presence. Nebulae bloom on plates like time-lapse flowers. The cumulative method changes the game. Seeing is no longer confined to a moment of glare. It becomes an act of harvesting. Accumulation bends faintness into visibility and gifts the night a deeper register. The extension of reach is quiet, almost domestic, yet it pushes the imagined frontier outward with each night of patient work. He sits with calculators who transform numbers into maps. Catalogues turn into atlases. Atlases become surveys. Surveys pick out structures so large that human metaphors struggle to keep pace. Filaments, walls, voids. The distribution of galaxies stops looking random and begins to look composed by a set of rules written at degrees that challenge intuition. The vocabulary of order, at grand scales, starts to seep into culture. A citizen of a small planet gains a right to pronounce the shape of regions far beyond personal travel. The confidence is not arrogance, it is the reward of cooperative measurement. He senses that the most surprising lesson from this lineage is simple. The idea of an edge grows not from a single revelation, but from a braid of small determinations. Speed of light, finite. Distance measurable by rhythm. Motion legible in spectra. Darkness as testimony. Geometry as law. Together, these strands weave a horizon that is logical rather than romantic. The boundary of what can be seen is not a rumor. It is a construction supported by instruments, arguments, and the humility of repeated checking. A traveler who inherits this heritage does not go in search of a cliff at the end of the world. He learns instead to read the sky as a document in which distance writes itself as time, and time writes itself as evidence. The result is not the end of mystery. It is the beginning of a more precise wonder. He faces a revelation that arrives not as thunder, but as a straight line on a modest graph. The points are galaxies, the axes are distance and recessional velocity, and the slope is a rate that rewrites the behavior of the whole sky. The plot says that farther galaxies flee faster, not at random, not by whim, but by a relation so clean it might be a law branded into the bones of space itself. He studies the quiet audacity of that line. It does not merely report motion. It declares that the fabric is stretching, that separation is a built-in rhythm, that the cosmos breathes with a measurable cadence. He sits with the shock long enough to describe it in plain terms. A universe once imagined as a mansion arranged by a timeless architect now behaves like a room whose walls recede while one stands still on the floorboards. The surprise is not that things move. Everything local moves through ordinary gravities and orbits. The surprise is that distance grows, because the metric that measures distance evolves. Rulers themselves change their spacing, and the change is uniform on scales large enough to ignore the tug of any single galaxy. The law that emerges from the graph seems almost simple. Double the distance, double the recessional speed. Simplicity in such company is unsettling. He recognizes that the idea of a static sky had a certain comfort. A fixed ceiling invites cataloging. An evolving ceiling demands history. With expansion, time acquires agency. Yesterday, the universe was closer to itself. Tomorrow, it will be farther. The concept brings consequences that touch every corner of thought. Light traveling through this environment does not merely cross emptiness. It rides a tide that lengthens its waves. What began as blue arrives as red, not because the source fled like an arrow, but because the interval between crests stretched while the light was en route. The spectrum becomes a diary written in longer syllables. He pictures an observer in a distant galaxy, making the same measurement and drawing the same line. That observer would place his own home at the center of the graph and find every other city of stars receding. The thought could have stirred a return to geocentric pride if taken naively. The proper lesson is subtler. No single place earns special status. The pattern looks the same from any vantage because the expansion acts everywhere with the same long breath. Center becomes a word without a referent. The shock that remains is a philosophical one. Humans must let go of the urge to stand at the middle of the design and accept membership in a symmetry that does not bend for anyone. He investigates how such an expansion could be lawful rather than chaotic. The mathematics of a flexible geometry offers a family of solutions that allow the scale of space to change with time. Mass and energy dictate the tempo. Curvature responds. The scale factor grows. There is nothing mystical in the mechanism. It is the logical behavior of a dynamic spacetime that honors the deepest principles of motion and gravitation. This calm rationality does not soften the emotional impact. A variable cosmos means origins are not only stories, they are calculations. Futures are not only hopes, they are projections drawn from the shape of the curve that ties recession to distance. He explores what expansion rescues and what it challenges. It rescues the dark night by preventing the endless pile-up of ancient starlight. It explains why distant spectra carry signatures shifted toward the long end. It redirects the mind away from a universe that has always been as it appears, and toward a universe that carries a history as real as geology. It challenges the comfort that comes with permanence. It asks every equation to be written with time in the foreground, because stability at grand scale is now a special case rather than the default state. He lets the mind test metaphors, careful not to be trapped by them. A rising loaf filled with raisins is a useful picture if one remembers that it is only a picture. The raisins are galaxies carried apart by the swelling dough. No raisin sits at the true center. Every raisin sees the others receding. The image works, but it must be handled with care, since galaxies are not passive lumps adrift in bakery. Gravity binds many of them into clusters that do not follow the general drift as faithfully. The expansion is a statement about the broad canvas, not a refusal of local portraiture. Within clusters, mutual attraction writes smaller stories that share a page with the global narrative. He follows the implications into the night of far futures. If the current tempo persists or quickens, more and more distant realms will slip beyond the circle of communication. The sky will grow sparse to any patient observer living long from now. Familiar patterns will fade as light from their sources wanes into undetectability. He is not tempted to call this melancholy. There is a quiet dignity in a horizon that approaches on its own schedule. Finite reach confers value on the act of looking well, while the looking is possible. Expansion turns curiosity into a time-sensitive art. He considers the craft of measuring the rate itself. The slope of the line on that first graph is not a universal constant like the speed of light or the charge of the electron. It is a parameter that can evolve. Determining its value demands yardsticks spread across cosmic cities and standardized candles whose true brightness is known. The calibration of those tools is a delicate business, and the answer has varied as methods improve. He admires the humility that accompanies every new measurement. Each revision is an acceptance that the cosmos sets the numbers, not opinion or tradition. The shock, in this light, is also an ethical lesson. Reality resists flattery. He studies the objection that all this might be a mere illusion of motion, a trick of perspective, or a quirk of local flows. The counter is strong because the pattern holds at scales too large for parochial currents. Flows can add embroidery, tugging some regions toward others like small breezes on a windy day, but the prevailing wind remains expansion. The consistency across direction and distance argues for a global behavior rather than a patchwork of local accidents. The sky would look different if the effect were a mirage. It does not. The linear relation persists where it should and breaks where gravity takes command, exactly as a coherent story would require. He watches the intuitive worry bloom and then settle. If distant galaxies recede at rates that grow with distance, are there places where the calculated recessional speed exceeds the speed of light? The answer is yes, and that yes is lawful. Velocity here is not a sprint through a fixed stage. It is the growth of the stage itself. No traveler outruns a beam within the local rules, and no message leaps beyond causality. The expansion can widen separation faster than light without granting any ship an illegal ticket. The clarity of this distinction relaxes the mind that first found the idea offensive. Language must bend a little to host a world so large. He notes how expansion converts the map of the universe into an atlas animated by time. Angles between constellations freeze across human centuries, yet the scale beneath them changes with a patience that eludes immediate sense. The presentable constancy of the dome deceives. Beneath the calm pattern lies a slow flourish. In this hidden theatre, clusters fall together, filaments grow from the smallest vibrations, and the vast emptiness between walls grows vaster still. The same law that lifts cities of stars apart also allows the emergence of structure from initial irregularities. Order can deepen while distance grows. That pairing is one of the most generous surprises of all. He contemplates the oldest light that still fills the night as a faint thermal glow. It preserves a snapshot of a universe young enough to be almost featureless, but mature enough to carry the seeds of future architecture. Expansion cooled that ocean of particles until transparency became possible. Without the stretching of space, the glow would sound different and the galaxies would not have found their scaffolding in time. The graph of recession is not an isolated curiosity. It harmonizes with the background murmur and with the distribution of matter at the largest scales. Harmony among separable measurements is a rare gift in any science. Here it underwrites a vision of a universe whose most dramatic property is quiet consistency. He takes one more look at the original straight line. It is a modest sketch by modern standards, yet it stands as a hinge. On one side lies a cosmos imagined as steady architecture. On the other side lies a cosmos that moves through eras, cools, forms, and will present different faces to observers who rise at different chapters. The shock is not violent, it is austere. A simple proportionality becomes a new grammar. He understands why many resisted the message when it first arrived. The reordering it demands is not about rearranging stars on a page, it is about changing the verb tense of the entire story. He lets the lesson conclude in ordinary language. The universe is getting larger in the sense that large-scale distances increase with time. The effect is measured, cross-checked, and woven into a framework that explains more than it disturbs. The surprise is how gently the truth presented itself. No explosion in the night, no sudden mismatch between theory and sight, only a row of points and a slope. He accepts the elegance of that restraint. Grandeur does not always advertise with spectacle. Sometimes it appears as a line whose meaning takes a lifetime to absorb. He listens for a whisper that does not ride air and discovers a glow that washes through everything, a faint warmth left over from an era when matter and light were inseparable. It is not seen by eyes. It is felt by instruments that can count the softest photons and weigh the slightest difference between one patch of sky and the next. Across the entire dome, the temperature varies by less than 1,000th of a degree. Yet inside that smallness is a map of almost everything large. He realizes that this glow is not an ornament, it is a relic. It carries the imprint of a time when the universe changed state and allowed light to travel, mostly unimpeded for the first time. He imagines a hot ocean of particles before the first atoms held together. In that ocean, photons bounced from electron to electron, like bees in a crowded garden. Visibility did not exist because there was no straight path for light to take. As the expansion cooled the medium, electrons found protons and settled into orbits. The fog thinned. In a brief interval, the scattering fell away, and the sea of light slipped free and started its long journey. The moment was not a single instant, but it was quick on cosmic terms, a transformation that turned opacity into transparency. That first great clearing left a shell around every observer, a surface from which most of the observed glow last interacted with matter. He recognizes that the word surface is a way to talk about time at a distance. The sphere is not a wall, it is a record of a transitional era now seen from within. He studies the delicate blotches in the temperature map, hot and cold by no more than tens of microkelvins. The pattern looks like a subtle marbling. Each feature is a fossilized sound wave. Before the fog lifted, pressure ripples rang through the plasma, compressing and rarefying matter and radiation together. The wavelengths of those ripples were set by the distance sound could travel before the clearing occurred. Where compression arrested, the glow on the sky appears slightly hotter or cooler. A cosmic drum froze mid-beat, and the notes are visible as a spectrum of angular scales. He understands that the pattern is not noise, it is a registry of vibrations that measure fundamental quantities. By reading the spacing and height of the statistical peaks in those ripples, one can infer the composition of the universe, the geometry of space, and the age since the first clearing. He considers how such a small signal can be believed. The answer is craftsmanship and patience. Detectors that sit above the atmosphere carry cryogenic hearts so they can sense differences as small as a few parts in 100,000. They scan the sky again and again until random errors cancel and coherent features persist. Balloons drift, satellites spin, ground telescopes sweep cold desert air, and all of them return maps that agree in their stubborn details. Agreement between unrelated methods is a hallmark of truth in the natural world. Here the harmony is strong enough to turn suspicion into confidence. He reflects on the geometry hidden in the mottling. If space were curved like a saddle or a sphere, the characteristic size of the blotches would appear stretched or shrunk. What is seen points to a geometry that is very close to flat on the largest scales. The word flat does not mean empty of drama. It means straight lines behave as they would on a plane when measured across expanses that overwhelm any local buckling. This reading, combined with other observations, implies that the contents of the universe add up in a way that leaves very little room for significant positive or negative curvature. The result is both austere and generous. It simplifies certain equations while allowing complexity to bloom inside a nearly Euclidean frame. He explores the way polarization adds a second layer of meaning. When light last scattered, the angles of those interactions imprinted a preferred orientation on the waves. Measuring that faint alignment reveals patterns that can be decomposed into two geometric families. One arises naturally from density ripples and velocity flows. The other requires swirls or tensor ripples in spacetime itself. The first has been measured with exquisite certainty. The second remains a frontier, a prize that would provide a window into a moment even earlier than the Great Clearing. He does not need to see that prize in hand to feel the value of the chase. The pursuit has already sharpened instruments and trained minds to tease signal from a fog of terrestrial interference and cosmic dust. He follows the photons along their route from the last scattering surface to the present. Their path is not perfectly straight. Gravity from intervening structures deflects them by tiny angles, blurring and distorting the original pattern. That weak lensing can be read backward to reconstruct the intervening web of mass, including matter that does not shine. Thus, the same glow becomes a backlight that outlines invisible scaffolding. He admires how a single signal serves multiple purposes. It is an archive of a phase transition, a ruler for space, a thermometer for composition, and a lantern that silhouettes the hidden skeleton of the cosmic web. He thinks about the slight broadening of the glow caused by later reionization. When the first stars and black holes ignited, their radiation reheated and stripped electrons from hydrogen in large regions, introducing a new round of scattering. This did not erase the earlier pattern, but it fogged it gently. From that gentle fogging, one can estimate when the first luminous structures lit the wilderness. The glow thereby connects a primordial transformation to the dawn of starlight, a thread that ties the earliest acoustic weather to the first organized beacons. He contemplates the smallness of the fluctuations and the largeness of their influence. Variations 1 part in 100,000 at the clearing time later grew, under the influence of gravity, into galaxies, clusters, and the great filaments that span hundreds of millions of light years. The map of tiny differences is a seed chart for everything structured. Obviousness is not a reliable guide in such matters. What seems too modest to matter can become the blueprint for splendor when given time and a universe that allows amplification. He examines the edges of the power spectrum, where the largest scales carry information with a mood bordering on philosophical. On those vast angles, patterns hint at the finitude of the observable patch and the specific history of the early universe. Some features invite debate, like the relative weakness of the largest hot and cold spots compared with certain expectations. Whether these are statistical flukes or signs of deeper stories is a question that inspires careful analysis rather than credulous wonder. He values this culture of restraint. The glow is precious enough without being asked to play every role. He notes a resonance between the early acoustic ripples and structures seen much later among galaxies. The preferred scale imprinted in the glow reappears as a gentle excess in the spacing between galaxy pairs. These echoes, preserved in the distribution of matter long after recombination, provide a second way to measure cosmic distances and expansion history. Two very different eras whisper the same number. The concordance elevates trust and turns a poetic image into a calibrated tool. He returns to the image of a curtain, not one that falls, but one that rises to reveal a stage prepared for later acts. The last scattering surface is a view into a young world that had already smoothed most of its wrinkles, while keeping the tiny creases required for structure. The smoothness tells of a process that evened temperature and density across regions that could not have communicated by light alone at that time. The creases tell of quantum seeds that survived the smoothing to outline the first scaffolding. He cannot name those processes without entering theory. He can, however, honor the discipline that extracts their fingerprints from the pattern. He appreciates the humility required to work with a background that fills every direction. Because it is everywhere, it is easy to mistake for nothing at all. The first discoverers encountered it as noise that stubbornly refused to go away. Only with persistence did the noise reveal itself as the signal. That lesson carries forward. Many truths first appear as annoyance, as a residue that does not submit to correction. Patience turns residue into revelation. The faintest glow in the sky carries more instruction than many bright explosions, simply because it belongs to all directions and all observers. He lets the scale close in again, to the level of a pixel on a map made by a satellite spinning in perpetual twilight. That pixel is a measurement of temperature and polarization taken with care, corrected for the glow of our own dust, adjusted for the dipole caused by our motion, cleaned of many layers of local interference. It takes a community to nurse each pixel into honesty. Multiply that by millions, and a portrait of the early universe emerges with a clarity that would have been unthinkable to earlier generations. The portrait is not a final truth. It is a faithful page on which other pages can rest. He draws a quiet conclusion. The faint microwave glow is the gentlest of horizons. It is not a boundary that says stop. It is a veil that says look. On this veil are written the notes of a cooling, the rhythms of early sound, the shape of space, and the hints of forces that governed the first moments. By learning to read it, he takes part in a tradition that finds grandeur in patience and meaning in small differences. Light that began as heat in a crowded chamber has travelled almost the whole age of the universe to arrive as a whisper. He listens, and the whisper speaks of beginnings with a calm that feels like truth. He studies shapes that do not need walls to be complete, and finds comfort in a geometry where endings are not required for finitude. A sphere offers the simplest lesson. Walk in any direction on its surface, and there is no corner to collide with, no rim to step over. The journey can be endless while the surface itself is finite. An ant travelling such a world would never discover an edge, yet the ant would not live on an infinite plane. The insight extends beyond pictures. Space can have global properties that are gentle and closed without erecting barriers that halt motion. He learns to separate two ideas that everyday experience tends to blend. One is the shape of space. The other is the presence or absence of borders. They are not the same. He imagines measuring with triangles. On a flat sheet, the angles of any triangle add to a precise sum. On a sphere, the sum is larger. On a saddle, the sum is smaller. These are not philosophical preferences. They are quantitative tests that a patient surveyor could perform with straight beams and long lines of sight. Translate the experiment to astronomy, and the beams become light, travelling from distant objects. The lines cross at an observer and at the sources. The total angle tells the story. If the grand sum equals the familiar rule, large-scale space is effectively flat. If not, it carries curvature that could be told in signs and magnitudes. He sees how the cosmos invites such experiments through the shapes imprinted on ancient light and the arrangement of distant galaxies. He contemplates the circumference of a circle drawn large enough to feel the universe beneath it. On a flat stage, the ratio of circumference to diameter is constant. On a curved stage, the ratio changes with radius. Place a bright standard ruler at a huge distance and watch how big it appears in the sky. If it looks slightly larger or smaller than the flat prediction, that deviation announces curvature. This trick, performed with cosmic rulers extracted from early sound waves and later structures, acts like surveying on a frontier where the tape measure is made of light and the stakes are galaxies. The result points to a broad flatness within small error bars. Flat does not mean bland. It means the vast canvas respects Euclid when averaged over volumes so enormous that local bumps vanish into statistical dust. He turns from curvature to topology, the study of how a space can be connected without metrics. A coffee cup and a donut are twins in topology because each has a single hole. Distances and shapes can be altered without changing that fundamental connectiveness. The cosmos could be similarly tricky. It could be globally finite by virtue of identifications that glue opposite faces together in subtle ways. A flat, three-dimensional space with such periodic wrapping is like a hall of mirrors where a traveller sees repeats of the same scenery in different directions. Light could circle the world and present multiple images of the same object from varied paths. He lets this possibility linger. A universe could be flat yet closed in a topological sense, offering no edge while enclosing a measurable volume. He explores how to detect such identifications. One method searches for matched circles in the map of ancient light. If the sky shows pairs of circles with identical temperature patterns, that might indicate that the observer sees the same physical ring from two directions because space wraps. Another method hunts for repeating constellations of galaxies, the same groupings appearing at different distances and orientations. So far, the sky does not confess to obvious repetitions within the observable reach, though the door remains ajar for more delicate signatures. He appreciates the honesty of a negative result. Not finding a twist is itself a piece of knowledge. He considers a closed space with positive curvature, the three-dimensional cousin of a sphere. Such a universe would be finite by geometry rather than by topology. Walk far enough in any direction, and a traveler would return to the starting point without ever touching a boundary. The volume would be limited, and yet the path would never meet a wall. Measurements of ancient light place stern limits on how large the curvature radius must be if this is the case. The radius would need to be much larger than the visible region, rendering the curvature gentle beyond easy detection. That gentleness would hide the closure from any survey that cannot see beyond the horizon of light. He looks as well at open spaces with negative curvature, where lines that begin parallel diverge forever. In such a world, triangles would have angle sums smaller than the flat value, and circles would own circumferences larger than expected. The visual effect at extreme scale would be a kind of grand perspective, as if the universe leaned away at the edges of vision. Again, the imprints on ancient light and large structures constrain how strong this curvature could be. The reading suggests that if the space is open in this precise sense, the effect is mild across the volume that can be observed. Mildness here is not disappointment. It is reassurance that the equations describing large-scale structure can be solved without contortions. He studies how local gravity buckles the canvas without changing the verdict at grand scale. Galaxies, clusters, and the filaments between them induce curvature that steers light and sculpts paths. Gravitational lensing reveals these local bulges as arcs and magnifications, yet average over regions 1,000 times larger, and the bulges wash out. The global statement about curvature survives the turbulent details. This hierarchy feels natural, like weather on a planet that does not alter the planet's roundness when averaged across oceans and continents. He reflects on the comfort that edgelessness offers to both intuition and method. Without walls, cosmic boundary conditions do not require special pleading. Equations evolve smoothly across the whole domain. There is no place where the rules must be adjusted to prevent impossible reflections or unphysical drains. The absence of a cliff is not poetic convenience. It is a practical simplification that permits predictions to be compared with observation without worrying over a rim that might bounce light or stop motion. He thinks about how a traveler would experience such a world if given endless time and an engine that never tires. In a positively curved finite space, a voyage straight ahead could return the traveler to a familiar sky from a new angle. In a flat space with periodic identifications, a repeating tiling of reality would scroll by, offering a pattern that repeats at intervals too large for any current instrument to reveal. In an open space, the view would grow forever but never close, with new scenery always forming at the edge of reach. None of these scenarios require a border. Each defines a different flavor of infinity or finitude written into the way paths behave. He examines the philosophical itch that edges often scratch. A mind raised on rooms and fences longs for a last object, a final post to touch. Geometry replies with a gentle refusal. The question changes shape when asked at cosmological size. A properly posed query is not where does it stop, but how does it connect. The point is not to discover a barrier. The point is to learn the grand relation among paths, the sum of angles, the shape of volumes, the fate of lines. In that light, the search for curvature and topology becomes a search for the universe's grammar rather than its perimeter. He respects the craft required to keep these inferences honest, measuring small differences in pattern, subtracting the glow of local dust, correcting for motions, modeling the effect of intervening structures, and comparing independent datasets all contribute to the patience that reliable answers demand. The numbers describing curvature arrive wrapped in uncertainties that shrink as instruments and methods improve. Those numbers seldom make headlines, yet they guide the choice between grand possibilities and keep speculation anchored. He allows one final image. Imagine a room with no walls, only rules. The rules determine how straight paths meet, how circles grow, how light takes the long way around when mass is nearby. Walking in such a room is not like exploring a cave that hides a final chamber. It is like tracing the steps of a dance whose floor extends without seam. The dance has figures that repeat, themes that reappear differently at different scales, and a rhythm that responds to the content of the room. None of this requires a border to make sense. He settles on a quiet summation. Space can be finite without edges, infinite without repetition, or flat yet cleverly wrapped. The evidence at hand favors an almost flat expanse across the observable region, with no detectable topological repeats within that reach. The large structures are carved by local gravity that bends paths while leaving the broad verdict intact. The concept of an edge loses its grip under such a geometry. What remains is a soft geography of rules that shape motion and sight, a landscape where finitude and edgelessness can coexist without contradiction. He notices that the single word edge is asked to do too much work and begins to separate meanings the way a lens separates colors. Each meaning points to a distinct boundary, each drawn by a different rule of time and motion. He starts with the light cone, the simplest diagram a thinking creature can carry in the mind. From any event, a future cone spreads, where influence may travel, and a past cone narrows to the messages that could have arrived. The visible sky lives inside that past cone. Anything outside could be real, but it cannot have spoken. The edge of the past light cone is not a wall in space. It is a deadline in time that divides the knowable by sight from the still silent. He then considers the particle horizon. This is the farthest distance from which light has had time to reach an observer since the first moments. Its radius depends on how the cosmic clock has ticked from the beginning until now. Expansion bends the accounting because light must cross a stage that changes beneath it. The particle horizon is a memoir of what has had time to say hello. It widens as the age grows, incorporating new regions into the circle of possible awareness. This horizon is historical. It tells who has managed to speak so far in a universe where conversation is limited by the pace of light and the length of the day. A different line appears in his notebook when he writes down the Hubble sphere. Take the present expansion rate and ask at what distance recession reaches the speed of light. That radius is not a horizon in a strict causal sense. It is a marker where recession, calculated from the swelling of space, equals the canonical speed. Photons beyond it can still approach if the rate slows, or if the photons move inward through regions where the effective recession is smaller. Likewise, nearby photons can be carried outward if the rate quickens. The Hubble sphere is a weather report for the current tempo, not a final border for influence. Confusing it with a true horizon leads to unnecessary drama. He sketches the event horizon next, and the tone becomes sober. The event horizon is the set of points from which no signal sent now will ever reach the observer, not even given endless time. It depends not on what has been possible so far, but on what will forever remain impossible. In a universe where expansion accelerates under a steady push, the event horizon is real and finite. Galaxies beyond that veil will never exchange light with the observer again. This horizon is a promise about the future. It divides potential friendship from permanent solitude. Its presence turns the cosmos into a collection of islands that drift apart until no ferry can bridge them. He brings these ideas together to compare their flavors. The particle horizon is a record of the farthest hello that could have arrived by now. The event horizon is a prediction of the farthest goodbye that can still be sent today and be heard eventually. The light cone is the geometry that frames both. The Hubble sphere is a snapshot of the present rate, a mile marker that can drift as the expansion law changes. If the expansion decelerates, the Hubble radius grows quickly, and light from beyond it can wander in. If the expansion accelerates, the Hubble radius grows more slowly or stagnates, and more regions slip into permanent inaccessibility. The relations are subtle enough that a mind must be careful with phrases like faster than light and unreachable. He recalls that not all horizons are cosmological. black holes write their own verdict on influence. Around a sufficiently compact mass, the escape velocity reaches the speed of light at a specific radius. Inside that radius, no path that aims outward can win. The horizon there is geometric and local, a property of the curvature near a collapsed object. It differs from the cosmological event horizon, which is global and woven from the asymptotic future. Yet the family resemblance is strong. In both cases, there is a surface that parts events into those that can send news and those that cannot. The parallel clarifies and misleads in equal measure. One must not imagine the cosmos as a single black hole inside out. The causes differ even if the mathematics wears similar clothing. He examines the apparent horizon, a more technical concept that depends on how light rays converge or diverge in a given slicing of space-time. In an expanding universe with the right properties, the apparent horizon lies near the Hubble sphere, but need not match it exactly. It acts like a practical boundary for observations and simulations, a region inside which light rays still manage to move inward on average despite the stretching of space. The precise location of this horizon is sensitive to the energy content and the rate of change of the expansion. For an observer working with numerical worlds, it becomes a useful working edge for calculating what influences what over cosmic time. He thinks about the role of acceleration in sharpening or softening these boundaries. When pressure in the cosmic inventory behaves in a way that pushes space to expand faster with time, the event horizon settles at a finite distance. If the push relents in the far future, the event horizon can recede, reopening lines of influence that would have been sealed. If the push grows stronger with no bound, the event horizon crowds closer and the sky fractures into isolated districts with cruel efficiency. The map of edges is therefore governed by the long-term character of energy and pressure, a fact that turns these definitions into diagnostics for the fate of communication in the universe. He imagines a photon born in a galaxy just inside the event horizon. It sets off toward the observer with the usual speed, but the stage expands beneath it. At first, the distance between the photon and the observer may grow in spite of the photon's effort, because the local recession outruns the flight. Later, if conditions allow, the Hubble radius grows to engulf the photon's position, and the photon begins to win, inching inward at last. Whether victory occurs depends on the detailed history of the scale factor. This narrative helps him resist simplistic intuitions about chase and catch at grand scale. What matters is not only the speed, but the changing yardstick that registers the race. He contemplates the practical meaning of each edge for astronomers who aim instruments at the dark. The particle horizon sets the ultimate radius of the observable sphere at a given time. No telescope can spy beyond it, because there has not been enough time for news to travel. The event horizon defines the farthest place that can ever receive a message sent today. It is a limit on influence rather than on sight. The Hubble sphere marks where recession matches light's pace now, which is interesting for intuition, but not a true embargo. The light cone is the strict bookkeeper, the boundary that cannot be argued away in any coordinate system. Knowing which edge is in play prevents confusion when one speaks of visibility, causality, or destiny. He recognizes how language can betray understanding. Words like beyond and outside come loaded with images of walls and rooms. In this subject, outside often means earlier, and beyond can mean never connectable rather than farther in a spatial sense. The horizons clarify the dictionary. A region can be present in the same three-dimensional space while being forever out of conversational reach because lines of cause and effect are caged by curvature and expansion. A careful speaker will prefer phrases like cannot exchange signals rather than cannot be approached, and will specify whether the claim refers to today's state or to all possible futures. He lets the math retreat for a moment and focuses on the emotional color of these boundaries. The particle horizon feels like a biography of patience. The event horizon feels like a line of farewell. The Hubble sphere reads like a daily forecast, useful but not binding. The light cone is a stern judge that allows only lawful testimonies into the court of observation. Each edge shapes a distinct kind of wonder. Together they replace a simple craving for a final rim with a nuanced respect for the multiple ways a universe can limit conversation without limiting existence. He examines how these horizons shift for different observers. Two travelers in relative motion, slice spacetime into now and later differently, and so the coordinates assigned to edges will differ. Yet the physical statements remain consistent. If a photon cannot reach one observer, it cannot be transformed into a messenger for another by a mere change of perspective. The invariance of light speed holds the story together. Horizons are not illusions of convenience. They are shared verdicts, rendered by the laws that all observers must obey. He thinks about what a future civilization might do with such knowledge. The presence of an event horizon turns resource gathering and communication into projects that must respect deadlines measured in billions of years. Networks of beacons could be built to harvest light from galaxies before they cross the line of no further contact. Archives could be forged to carry messages inward against an ever-thinning stream of news from afar. The awareness of edges turns astronomy into ethics by assigning responsibilities to knowledge. It asks a culture to decide how to spend attention while the corridors of communication are still open. He closes the notebook with a calm assessment. The word edge hides a family of boundaries that are related but not identical. One speaks of the farthest sight, one speaks of the last conversation. One speaks of today's balancing point between race and reach. One speaks of the pure logic of influence in space-time. Sorting them is not pedantry, it is clarity. With clarity, the cosmos becomes less like a riddle and more like a score that any careful ear can read. The surprise is that edges multiply the more closely they are examined, and with that multiplication, understanding deepens instead of fraying. The night offers no single rim. It offers a set of quiet verdicts on what can be shared, when it can be shared, and what will always remain a private event in a distant district of reality. He hears a phrase that sounds like a contradiction and learns to untie it with care. Faster than light has the flavor of law-breaking, a daring sprint past the universal speed limit. Yet a universe that stretches can carry distant shores away at an apparent rate that exceeds any ship of photons without tearing the rulebook. The key is to watch the stage rather than the actors. Matter moves through space with the ordinary restraint that light imposes. Space itself expands, changing the distances between markers even when the markers nap. Distances that grow by the action of the metric are not the same as velocity in a hallway. Confusion dissolves when the distinction is held steady. He pictures a grid drawn on a flexible sheet. Coins are placed at the intersections to represent galaxies that barely stir against local gravity. Hands pull gently at the sheet so the squares widen. No coin slides across its neighborhood. The spacing between coins increases because the cloth changes size. If the pulling continues, coins at the far edges of the sheet leave one another behind faster than a coin could ever skate across fabric. There is no collision with a limit here because the coins are not racing, the growth is in the measure itself. Translate this picture to the cosmos, and the coins become cities of stars held together by gravity, and the sheet becomes the scale factor that turns co-moving separations into proper distances. The rules that bar ordinary motion past light speed still hold. The widening is a change of map scale written into the geometry. He considers a photon traveling toward an observer from a remote galaxy. The photon moves at light speed in any small region, as demanded by the most stubborn law in physics. Yet at first, the gap between photon and observer can increase, because the regions in between are expanding fast enough to outpace the photon's progress when measured as a global separation. Later, as the expansion rate per unit distance declines, or as the photon's location drifts into territory where the effective pace is less punishing, the photon begins to make headway. Eventually it arrives, tired only in the sense that its wavelength has stretched. The color has slid toward the long end of the spectrum because the scale of space grew as the wave crested and troughed. The redshift is not a Doppler blur from a source fleeing through static scenery. It is a record of the stage changing while the photon danced. He explores coordinates, the way a navigator picks maps for different tasks. In co-moving coordinates, galaxies at rest with respect to this flow sit on constant labels, and the expansion is absorbed into the factor that turns coordinate gaps into meter sticks. In proper coordinates, distances at a given cosmic time swell as the factor increases. Both views are honest. Each clarifies a different question. Confusion arises when the language of one map is carried into the other without translation. Speeds that appear to exceed light in one description are revealed as harmless changes of scale in the other. Definitions are discipline. Without them, outrage replaces understanding. He examines the role of gravity in setting the local exception to the global drift. Inside galaxies and clusters, mutual attraction overwhelms the gentle pull-apart of expansion. Stars in a spiral do not drift away from their neighbors because the local well of gravity holds them in a mutual embrace. The same holds for planetary systems and for the daily world of rivers and stone. The expansion matters on scales where the average density is low and the canvas stretches almost uniformly. The universe permits both conditions to coexist without friction. Binding writes local stories, stretching writes the global one. He returns to the question of causality, the thread that keeps physics coherent. The speed of light enforces the separation of cause and effect inside any local patch where rulers and clocks are defined by nearby processes. That speed is not a negotiable preference. It is built into the texture of space-time. Metric expansion respects it by never allowing a local messenger to outrun a light ray in its own neighborhood. Apparent superluminal recession arises only when global distances are compared across regions that share no common clock or yardstick. Causality survives because influence propagates along light-like or slower paths that respect the local geometry at every step. No paradox is born, no signal arrives before it is sent, and no riddle of grandfather and child is staged on a cosmic platform. He contemplates extreme histories where the stretching happens suddenly. In an early episode, expansion could have quickened to an astonishing rate for a short time. Ironing wrinkles and separating regions faster than light could knit them. That kind of accelerated growth does not ask material objects to break the limit. It uses the freedom of geometry to change scale. The consequence is a universe that looks uniform on large distances, with tiny quantum seeds left to be amplified later. Even in such violent tailoring of the fabric, the threads of causality do not snap. They simply find themselves attached to a garment that grew while they were being woven. He thinks about the way astronomers discuss recession speeds greater than light without flinching. A distant galaxy can have a recessional rate calculated from the product of its co-moving distance and the expansion rate that exceeds the canonical speed. No message is conveyed by that number. It is a bookkeeping device that reports how quickly proper distance grows. If the rate of expansion evolves, a photon emitted from that galaxy may still find its way to an observer later. If acceleration dominates, the same photon may fail to make headway forever. The numbers are sober, not scandalous. They are invitations to follow the detailed history of the scale factor rather than throw up hands at a misused limit. He imagines a local rocket attempting to cheat by harnessing the cosmic drift. The pilot cannot make a pocket of space expand selectively around the ship with ordinary fuel. Geometry on demand is fantasy. Known physics allows curvature to respond to energy and pressure in aggregate across the universe, not to the whim of one engine. Speculative metrics that compress space in front and expand it behind are mathematical constructs that do not pass the test of realistic energy conditions with known matter. The distinction guards the boundary between thought experiments that clarify definitions and machines that would break a law. Definitions remain safe, even as imagination plays along their edges. He reflects on distances as travelers experience them. Radar ranging measures how long a signal takes to go out and back. That time accumulates while the stage itself stretches. Converting the delay to a distance demands a model of how the scale factor changed during the trip. There is no single intuitive number called the distance for far objects that suits every purpose. Light travel time distance, angular diameter distance, and luminosity distance each answer different practical questions. Some grow with redshift, some peak and then decline. Some depend intricately on the ingredients of the cosmos. The diversity is not complication for its own sake. It is honesty about what it means to compare here and now with far and then in a universe that evolves. He watches a pencil of light graze, a massive cluster and bend. The lensing angle exposes the curvature created by matter and energy. This bending occurs within the local light cone, entirely subliminal and wholesome. Yet by tracing many such bends across the sky, a map emerges of structures that grew while space stretched. The map does not require any messenger to exceed light speed. It uses light as a reporter that remains faithful to the rule even as it reveals phenomena that spawn phrases like superluminal expansion to people who have not learned the careful dialect. He considers jets from the hearts of bright galaxies that appear to move across the sky faster than light when imaged at different times. The explanation rests on geometry and timing. A blob racing almost directly toward the observer at a speed near light emits flashes that arrive closer together than expected, while the angular separation on the sky increases modestly. The ratio of separation to time between arrivals can imply a transverse speed that seems to exceed the limit. In truth, the blob never outruns light in its local frame. Perspective conspires with near light speed motion to deceive intuition. Again, the rule survives. The apparent violation educates by its subtlety. He takes one last step back to see the pattern. A single speed limit governs local processes with iron calm. A separate freedom allows the scale of the stage to change, creating apparent separations that grow faster than any runner could achieve on a fixed track. Observers must keep these categories apart when they speak. If they do, the phrase "faster than light" becomes a cue to ask which measure is being used, rather than a verdict of impossibility. Lawfulness and grandeur coexist. The universe keeps its contracts while permitting distances to swell beyond any private exertion. He ends with a simple image. Two lanterns float on a lake whose surface slowly rises. No boat rows between them. The water itself lifts and spreads. The lamps grow farther apart, without the breeze, without oars, without current. Their light obeys the same old rule, taking time to travel, fading as it goes, reddening if the water pulls the ripples wider. Nothing cheats, everything changes. The paradox becomes a lesson in categories, and the lesson becomes a calm. Faster than light is not rebellion here. It is the large-scale grammar of a world that honors its speed limit locally while letting the distances breathe. He turns his attention to the possibility that space might be clever with its connectives, not merely curved or flat, but stitched in a way that lets light return from directions that seem unrelated. A room can feel boundless if its walls are mirrors that tile the view with endless copies. He wonders what the cosmos would look like if, far beyond any reachable star, opposite faces were silently identified so that a ray of light leaving toward one compass point re-entered from another after a grand tour. In such a world, a traveler could march forever without finding a border, and yet inhabit a volume that repeats. Infinity would be a perception rather than a measure. He entertains the simplest case, a three-dimensional torus. Imagine taking a cube and gluing each pair of opposite faces so that crossing one boundary deposits the traveler back through the opposite face with orientation preserved. Locally, nothing looks odd. Straight lines remain straight. Triangles respect the familiar sum of angles. Globally, however, any pattern repeats in a lattice that extends without end in the coordinate sense, while the physical content is confined to a fundamental cell. Light would weave this structure with patience, passing through tiles of the same world until it returns. To an observer placed anywhere inside, the sky could contain ghost images of the same galaxy at different apparent distances and ages. The idea is not fantasy born of poetry. It is a rigorous proposal about connectivity that does not contradict the local rules of measurement. He then explores more intricate possibilities. A dodecahedral space identifies pentagonal faces with a twist, forcing light to return with a rotated orientation after circumnavigation. Lens spaces apply different rotational matchings. Each topology writes its own signature into the sky. The patterns would not be arbitrary. They would arise from repeated passages of light along closed geodesics, producing preferred orientations and pairings that a patient analysis could detect. Topology here is the art of sewing without seams, and the stitches are invisible except through the choreography of light. He imagines how to search for such sewing. Ancient light provides the cleanest canvas. If the observable region sits within a multiply connected space, small enough relative to the distance to the first visible shell, then that shell would intersect itself. The intersection would produce pairs of circles on the sky with matching temperature patterns, the same acoustic ripples seen along different great circles. The alignment, size, and orientation of these circles would depend on the precise identifications. The task becomes one of matching rings, an exercise in pattern recognition, filtered through rigorous statistics to avoid fooling oneself with random resemblances. He considers another approach known informally as cosmic crystallography. Distances between bright tracers such as galaxies can be plotted to see if the distribution carries a comb of preferred separations. If space repeats with a fundamental scale, certain gaps would recur more often than expected in a simply connected expanse. The analysis must be cautious, since clustering from gravity introduces its own preferences. The search, therefore, relies on large, clean surveys and on subtracting the expected imprint of ordinary structure to reveal any extra resonance introduced by wrapping. He turns to the practical obstacles that make the hunt demanding. Any ghost image of a galaxy would be drawn from an earlier cosmic epoch, since the multiple paths differ in length. A single physical system would appear at distinct ages, dressed differently across millions or billions of years, perhaps in another stage of star formation or after a collision that altered its shape. Recognition would require more than superficial resemblance. Spectral fingerprints, relative alignments within groups, and statistical consistency across many candidates would be needed. The unkindness of cosmic weather, with its mergers and flares, conspires to blur the echoes. He thinks about polarization of ancient light as a second channel of evidence. The same circles that might match in temperature would also show correlated polarization patterns due to the geometry of last scattering. Polarization offers a stricter test, less easily mimicked by chance alignments. Measuring it, however, demands instruments that can weigh angles of orientation with exquisite sensitivity across the full sky and can peel away the confounding glow of foreground dust. The difficulty is a virtue in disguise, since success would be correspondingly persuasive. He pauses to note that multiply connected spaces do not require any violence to create. They can arise as perfectly legitimate solutions of the equations that govern geometry, differing only in their global identifications. The local physics of stars and atoms would not change. The novelty lies entirely in how large loops thread the world. Such moderation appeals to his sense of elegance. A big surprise does not need loud mechanics. It can be hidden in topology, a quiet choice of how to close a shape. He contemplates the philosophical scent of a repeating universe. If a fundamental cell were small enough, the night would be filled with copies. Every direction would ultimately return the same catalogue of structures at various stages. An observer could, in principle, draw a map that closes on itself, marking pathways that begin and end at the same place after wrapping through the hidden identifications. The loss of an outer boundary would be compensated by an inner pattern that speaks of completion. Finitude would wear the clothes of infinity while retaining the intimacy of a contained whole. He considers the opposite possibility as well, one in which the fundamental scales of connectivity are so large that the observable region contains no repetition. In that case, the universe could still be multiply connected, but the evidence would lie beyond sight. The lack of matched circles or repeating separations would not refute multiplication. It would only set a lower bound on the scale of the sewing. He sees the humility in such a conclusion. Sometimes the best answer is a constraint, a measured silence that says the room, if tiled, is tiled with squares too broad to notice from the present vantage. He explores the distinction between topological repetition and gravitational lensing, since both can create multiple images. Lensing bends light around mass concentrations, producing arcs, rings, and doubled sources with different brightness and delays that depend on the mass along the path. Topological images, in contrast, would not require an intervening lens. Their separations and orientations would be governed by global identifications and would appear across the sky in patterns that ignore the local distribution of matter. Timing differences would trace the lengths of closed geodesics rather than the variable potentials of clusters and galaxies. The sky is generous enough to host both effects, and careful analysis can tell them apart. He imagines a discovery in which a set of galaxies appears in a telltale configuration, repeated with a rotation and a parity flip at a predictable angular separation, their spectra bearing kinship that cannot be explained by chance or lensing. The relief among skeptics would not come from romance but from consistency. The same identifications that explain the patterns would also predict specific matched circles in the ancient light and a comb in separation statistics. Multiple clues would lock together, and the case would move from suggestion to architecture. He recognizes how rare such convergences are, and therefore how valuable. He appreciates the practical benefits that a confirmed topology would deliver. Knowing the connectivity would turn the sky into a closed survey. The fundamental domain would be finite, and one could count the number of large structures it contains without extrapolating into darkness. Cosmological parameters that suffer from degeneracies in simply connected models might be sharpened by the extra information in the repeating boundary conditions. Even the interpretation of fluctuations in ancient light would adjust, since modes larger than the fundamental scale would be absent or altered by the wrapping. He lets imagination offer one more image, careful to keep it anchored. Picture a lighthouse on a coastline that curves back on itself under a fog. Its beam sweeps, and after a long delay, a faint echo of the light returns from the opposite direction, not as reflection, but as the beam's own path around the world. The keeper, attentive to angles and timing, could deduce the size and shape of the bay despite the mist. The cosmos might offer a similar chance to attentive minds if the connectivity is tight enough to allow the echoes to return within the reach of instruments. He closes the meditation with a balanced verdict. Multiply connected topologies remain possible residents of the cosmic catalogue. They make specific promises about patterns in ancient light and the layout of distant structures. Searches continue with growing sensitivity, able to rule out small fundamental domains with increasing confidence while leaving more spacious connectivities in play. The thought that the universe could fold back on itself without a seam remains one of the most graceful surprises on the table. It replaces the hunger for an outer edge with the invitation to look for inner rhyme, a subtle repetition that would turn the largest stage into a finite theatre with no curtain and no wall, only paths that lead home by routes no traveller can exhaust. He approaches a moment when the universe learned the art of rushing and finds that speed can be gentle when it acts everywhere at once. Imagine a field without texture filling space, heavy with potential energy, pressing on the fabric as evenly as breath on glass. While that pressure dominated, distances did not merely increase. They swelled with a steadiness so rapid that any fixed ruler would be left behind in a blink. The effect ironed out irregularities, stretched tiny ripples into continental curves, and turned the young cosmos into a near-uniform sea. Expansion here was not the slow tide of later eras. It was a surge that doubles and doubles again, a cascade of E-foldings that changes a microcosm into a realm large enough to host every later story. He studies why such a rush makes sense. A universe that begins hot and dense, yet expands at a modest pace, carries puzzles that refuse to sit quietly. Regions on opposite sides of the sky share nearly the same temperature, yet ordinary communication could not have passed between them in time to agree. Curvature, if set without care, tends to grow as space evolves, yielding a geometry that departs wildly from the flatness surveys report. Relics from high-energy transitions could have survived as stubborn exotica in quantities the night does not display. A brief epoch of uniform acceleration addresses these soars in a single stroke. Areas once close enough to mingle are pulled apart until they lie far beyond mutual contact, preserving their shared temperature as a worldwide fact. Curvature is diluted by the swelling in the same way that wrinkles smooth when a sheet is pulled tight. Exotic leftovers are thinned until they become needles in a cosmos-sized haystack. He gives the driver of this behavior a simple name, a scalar field with potential energy that changes slowly as the field rolls can act as a near-constant energy density for a time. Constant density in an expanding world yields steady negative pressure, and negative pressure encourages acceleration by the rules that tie geometry to energy and stress. The details matter, but the picture can be told with a clean line. A field high on a gentle slope rolls so lazily that its potential dominates over its kinetic haste. While perched, it fuels the surge. As it descends and the slope steepens, the dominance ends, the rush slows, and the ordinary mixture of radiation and matter takes over. The field's dawdling is the secret of the smoothing. He sketches the clock that times the rush. The number of E-foldings counts how many doublings occur during the episode. A tally of 60 or more is often enough to explain the plainness of the large-scale sky. Less than that leaves too much memory of initial curvature or temperature variation. More than that is allowed but not demanded. The exact count depends on the later thermal history, on how the field surrendered its energy to particles, and on the temperature at which the fireball phase began. This dependence ties the most violent calm to the later chemistry of galaxies and stars. A clean connection across such a span of time feels like a gift. He turns to the quantum seeds that inflation stretches. Even a field sitting quietly is not perfectly still. Quantum fluctuations rattle it with tiny uncertainties. During rapid swelling, those ripples are pulled beyond the local horizon, freezing their phase and amplitude as classical variations in the field value from place to place. Later, when the rush ends and the horizon grows in co-moving units, these frozen patterns re-enter as density variations in the material world. Gravity amplifies them. The result is a relic spectrum of initial inhomogeneities that carries a hallmark shape, nearly scale invariant, slightly tilted, almost Gaussian, and coherent in phase. From such modest beginnings, the scaffold of clusters and filaments grows. The mathematics that ties a field's potential to this spectrum is compressed into two slow-roll parameters, tiny numbers that report how gently the field descended its slope. Small values mean a long, smooth surge, and a spectrum that matches the sky's quiet marbling. He asks how the rush dimmed into the heat of the young fireball. The field must give up its stored energy to a broth of particles. That conversion could happen through steady decays that dribble energy into lighter quanta, or through a period of parametric resonance called preheating, in which the oscillating field dumps energy explosively into certain modes that then thermalize. Couplings control the handoff. The temperature of the resulting plasma sets the starting point for ordinary expansion under radiation's rule. The efficiency of this process leaves fingerprints in relic backgrounds and in the abundance of particles that were never again in equilibrium. Knowing the handoff precisely would close a gap between a smooth mathematical episode and the messy chemistry of the subsequent world. He listens for a deeper drumbeat that might accompany the seeds. If space-time itself wrinkled during the rush, a spectrum of primordial gravitational waves should have been excited, stretching and freezing like the density ripples but with a different signature. Such tensor modes would leave a faint curl pattern in the polarization of ancient light, a subtle imprint that acts as a seismograph for the earliest tremors. The amplitude of this signal ties directly to the height of the potential that drove the rush. Loud ripples would point to a lofty energy scale, quiet ones to a more modest plateau. The search is delicate because galactic dust and other contaminants draw their own curls, and instruments must weigh them all to separate whisper from static. A firm detection would turn a graceful idea into an audible event. He keeps the alternatives honest. Inflation is a family name, not a single script. Potentials can be monomials that roll steeply, plateaus that linger, or hybrids that involve more than one field. Some versions predict stronger tensor ripples, others predict nearly none. Some prefer a slightly red tilt in the spectrum of seeds, others flirt with features or running. Each variant faces tests drawn from temperature maps, polarization maps, and the layout of galaxies at vast distances. The balance between elegance and evidence shifts as new data tighten constraints. The landscape of models evolves by pruning. Hypotheses that overpromise are set aside. Curves that fit too finely without good reason are viewed with suspicion. He examines a provocative consequence that turns the rush from a single episode into a possible habit. In certain potentials, while one patch of the field rolls down and ends its surge, other patches sit higher due to quantum fluctuations and continue to fuel expansion. The result is a mosaic of regions where inflation never entirely shuts off. New patches bud faster than old patches finish. The stage becomes a foam of growing pockets, each ending in its own way, with its own thermal handoff, possibly with different physical constants and particle contents. This eternal inflation offers a mechanism for a vast congregation of island universes. The idea carries explanatory appeal for certain coincidences that look unlikely in a single world. It also brings discomfort, for it challenges the habit of relying on probability where samples are uncountable. and selection effects are poorly defined. He treats the possibility like a cliff seen through mist. It is there on some maps, but the approach must be cautious. He wonders whether such pockets could brush one another and leave bruises on the sky. A collision between domains would imprint patterns in ancient light that could be hunted by careful statistics. Circular scars, asymmetries in large-scale temperature, or shifts in polarization could be hints. The absence of clear evidence limits how many and how violent such meetings could have been within our observable neighborhood. Limits are not disappointments in this work. They are rails that guide imagination between gulfs. He takes stock of what the surge explains without straining and what it postpones. It answers why far-flung regions agree on temperature. It yields the near flatness that measurements favor. It provides a natural source for initial seeds whose spectrum agrees with maps. It thins unwanted relics to irrelevance. At the same time, it delegates the question of ultimate beginning to the backstage. The surge may require special initial conditions of its own, a patch calm enough and high enough on the potential to start the roll. Some theorems suggest that even in such a world, a boundary in past time remains, requiring physics beyond the simple field story to complete the tale. He accepts that not every good idea is a final one. He presses on specific numbers that any theory must respect. The scalar spectral index should fall just shy of unity, reflecting a slight red tilt. Non-Gaussianities must be small if the seeds are born from a single, smooth field rolling gently. Isocurvature perturbations, which would signal independent fluctuations in components rather than overall curvature, must be tightly limited. The ratio of tensor to scalar power must fall below levels set by the absence of detected curl patterns. These guideposts carve a corridor through the forest of proposals. Within this corridor, models live or die by their details. Outside it, models step into the open where data can see them easily, and many have been seen and dismissed. He ends by drawing a quiet picture. Picture a window pane in midwinter that fogs and then clears as warmth changes the air. Etched on the glass are delicate patterns that formed while the pane knew a different state. Later, the room fills with conversation and heat, but the frostwork lingers as a memory if one looks closely. Inflation is like the clearing, and the frost-like patterns are the seeds it left. The room afterward is the hot plasma, where light and matter learn to travel together, and later still the cooled halls where stars arrange themselves along invisible scaffolds. The surprise is that a brief and nearly featureless episode can be responsible for so much structure. The elegance lies in how little is required. A field, a slope, a slow roll, a graceful exit into heat, and the patience to read faint ripples that survived the rush. He senses a pressure that does not feel like pressure, and learns that emptiness can carry its own insistence. Gravity is expected to gather, to slow, to bind. Yet measurements of distant candles and the scaffolding of large-scale structure reveal a different temperament at grand scale. The expansion of space is not only continuing, it is easing its foot from the brake and finding the accelerator. Distances grow with a pace that increases. The simplest reading points to a form of energy that does not thin in the usual way as the universe dilutes. This ingredient behaves as if every cubic meter of space keeps a tiny, steady deposit of energy within it, so that as the volume swells, the total grows. The effect is subtle locally and decisive globally. A small whisper repeated everywhere becomes a chorus that sets the tempo of the future. He gives this ingredient a working name, vacuum energy. In equations, it appears as a constant curvature term, a uniform density with a pressure that is negative in the measured sense. Negative pressure sounds like poetry until one writes the rule that joins pressure to the gravity of the whole. In that rule, enough negative pressure produces repulsion on cosmic scales, not a push between nearby masses, but a change in the curvature that makes free paths diverge faster. The outcome is acceleration of the scale factor. The same framework that let mass pull now allows the vacuum to ease apart. He asks how to weigh such a ghost. Light from a standard candle grows fainter with distance as energy spreads over a sphere and as redshift steals vigor from each photon. If the expansion has accelerated, the candles at a given redshift sit farther away than in a universe that merely coasts or slows. Their brightness, plotted against redshift, leans toward a curve that requires the extra ingredient. Independent rulers speak as well. Preferred separations in the distribution of galaxies act as yardsticks that stretch across the present and into the past. Their angular sizes and redshift positions trace the history of expansion with a different logic than candles. Ancient light, in its fine pattern, also depends on the distance to the clearing era and on how structure has grown since then. When many methods agree, suspicion yields to trust. The weight of the evidence gathers around a picture with a significant share of the energy budget locked in an entity whose pressure-to-density ratio hovers close to -1. He studies that ratio as if it were the pulse of the sky. The equation of state parameter, written as W, compares pressure to energy density. Ordinary matter has W near 0, radiation has W near 1/3. A constant vacuum energy has W exactly -1. Any deviation from that value would hint that the pressure and density evolve with time. Measuring W and its change is a central task because it separates a true constant from a field that drifts or a modification of geometry itself. Telescopes and surveys therefore act like cardiographs, recording the pulse across redshifts to see if the heartbeat of acceleration speeds, slows, or holds a steady rhythm. He entertains the simplest hypothesis first: a cosmological constant, no rolling field, no elaborate mechanism, just an irreducible energy of the vacuum that remains fixed as space grows. The elegance is strong. The burden is also strong. Quantum fields, when asked for their zero-point energy, reply with numbers that tower over the gentle value the sky seems to prefer. The disparity is absurd by any ordinary measure. Either cancellations nearly perfect hide a vast reservoir, or the counting must be rethought. He sits with the discomfort rather than flee to decoration. Sometimes nature is austere and unsettling. The constant may be real, even if its size is a riddle. He then considers a dynamic cousin. A slowly changing scalar field, often called quintessence, can provide negative pressure today if it moves leisurely down a shallow potential. Unlike a constant, such a field allows W to differ from -1 and perhaps vary with time. It could track other contents in the past and come to dominate more recently, easing certain coincidences about timing. The cost is complexity. Potentials must be shaped just so to fit the measured pulse without creating signatures that are not seen. Couplings to ordinary matter must be weak enough to avoid fifth forces that laboratory experiments would have detected. Screening mechanisms can hide such couplings in dense regions while allowing influence in the thin cosmic medium. Each proposal threads a needle stitched by observation and experiment. He does not let geometry itself escape scrutiny. Perhaps the left-hand side of the field equations requires revision at the largest distances. Modified gravity can mimic acceleration without an exotic fluid. Extra terms that grow important when curvature is small, new degrees of freedom that alter how structure forms, or leakage into additional dimensions can be introduced. These ideas carry specific fingerprints. They often change the rate at which clusters gather and the pattern by which light is deflected by mass. The same expansion history can be achieved with different physics, but the growth of structure and the bending of light discriminate among them. Observations of galaxy clustering, weak lensing shear, and motions within potential wells become tests of whether the vacuum is active or the rules of curvature have been edited. He imagines the far future written under continued acceleration. As time flows, more galaxies cross the event horizon defined by the new tempo. Their light never arrives past a certain epoch. The local group drifts toward a quiet isolation, lit mostly by its own inhabitants, backgrounds cool and thin. The deep silence grows deeper. Inside such solitude, observers might mistake their island for the whole if they lack records from an earlier age. The thought is not bleak. It is a reminder that cosmic context is a privilege of timing and that archives carry a moral weight in a world where horizons tighten. He searches for clues that lie beyond averages. If dark energy is truly uniform, it will not clump. Its influence will be smooth and gentle. If it is a field that responds to environments, subtle spatial variations could arise. mapping the integrated effect of all masses on light across the sky and comparing that map with the distribution of luminous matter offers a way to look for departures that suggest extra agents at work. Cross-correlations between ancient light lensing and late-time structure sharpen the view. So does the census of clusters as a function of mass and redshift, since acceleration resculpts the timetable for their assembly. The goal is not only to fit the distance data, but to match the entire choreography of growth. He revisits the curious coincidence that acceleration becomes significant when matter density falls to roughly the scale of the vacuum density. Why now is a question both simple and dangerous. Some answers invoke selection, noting that complex structures and witnesses may be most likely to arise in epochs when acceleration has not erased the ladder of formation. Other answers search for mechanisms that tie the vacuum value to the scale at which galaxies become common. The first route leans on statistics over large ensembles of possible worlds. The second leans on yet hidden symmetries or feedbacks. Neither option is free of challenge. He accepts the unease and treats now as a data point that requires an explanation, or the humility to admit that the explanation is not yet in hand. He wonders about the quantum underpinnings. Vacuum energy is not an abstraction tossed into equations as filler. Fluctuations exist in measurable ways. Forces between plates, shifts in energy levels, and the polarizability of the vacuum all testify that fields do not sleep even when left alone. Translating those facts into the gravitating energy of the whole, however, is not straightforward. Renormalization that works in particle physics collides with gravity in ways that leave large subtractions without a principled anchor. Efforts to couple the two more cleanly continue, exploring ideas where vacuum contributions are sequestered, where gravity responds only to deviations from a baseline, or where the graviton itself carries properties that dilute sensitivity to zero-point energy. Each approach must produce a universe that looks like the one the sky yields when interrogated with all available methods. He keeps an eye on the calendar of instruments. Larger surveys of galaxies at many redshifts will refine the yardsticks written into their spacing. Lensing maps that trace the invisible mass will grow sharper, turning the sky into a relief map of gravitating structure. Spectroscopic time series of supernovae will pare down systematics. Radiocartography of hydrogen's faint line across cosmic history promises a tomographic view of expansion and growth. Pulsar timing arrays and space-based gravitational wave detectors may add new rulers that act at yet unexplored epochs. The strategy is clear. Measure the distance history, measure the growth history. Compare them under different hypotheses until one story remains. He draws a scene of ordinary life to hold the abstraction steady. Imagine a room that expands so slowly one barely notices. A scent placed in the air thins as the room grows. Now imagine a faint device that exudes fragrance at a fixed rate per unit volume, so that as the room enlarges, there is more of the device because there is more room for it to inhabit. The scent does not thin as much as expected. After long hours, it begins to dominate. People in the room feel the difference without touching any new object. The device is not a fan. It does not push the air. It enriches the background everywhere. Dark energy is like that quiet device. It does not shove galaxies apart with gusts. It fills the stage with a property that makes geodesics diverge more quickly. He ends the meditation with a sober admission that does not dim wonder. The accelerating universe is one of the clearest, large-scale facts available, and yet the identity of its driver remains uncertain. A constant fits elegantly and frustrates deeply. Fields can emulate the effect with more parameters, but must pass tests that grow sharper each year. Altered gravity can reproduce the distance record, but must yield the observed pattern of growth and bending. The next steps are not heroic guesses. They are measurements repeated with patience and cross-checked in ways that leave no room for convenient errors. In the waiting, there is a calm. The sky has told enough to guide the work. It has not told everything. That reserve of silence is not a failure. It is an invitation. He enters a chamber of deliberate darkness, where mirrors drink starlight for weeks and give it back as portraits of beginnings. A deep field is not a place. It is a decision to stare at almost nothing until nothing confesses that it is crowded. Point a telescope at a patch of sky where no bright stars intrude, hold the gaze steady, and stack the faintest whispers of light until they rise above noise. The method is patience weaponized. From patience comes revelation. Flecks appear that are not dust on a lens but galaxies at distances so large that their light set out when the first heavy elements had not yet seasoned the gas. A simple rectangle of sky becomes a time capsule. He feels the thrill that comes from lifting a veil using nothing more than endurance and a camera designed to count single photons. He studies how these portraits are chosen. The field must be bland in the local sense, so that nearby stars do not swamp the view. It must be rich in the cosmic sense, so that the pencil beam intercepts a representative slice of structure rather than an unlucky void. Avoidance of zodiacal glow and galactic cirrus matters. The telescope points for many nights, sometimes for months, accumulating exposure that would be impossible from the ground because air is restless and bright. Raw frames betray cosmic rays and detector quirks. Calibration files and careful algorithms press the chaos into order. What remains is a tapestry woven from light that began its journey when the universe could count its age in hundreds of millions of years instead of billions. He learns to recognize the fingerprints of distance without a ruler. The ultraviolet light born in young stars is eaten by neutral hydrogen at a specific threshold. As the universe expands, that threshold slides to longer wavelengths. Galaxies at extreme redshift disappear from filters that sample bluer bands and reappear in a redder band. The technique is called a dropout method. It is as simple as a magic trick and as strict as spectroscopy when applied with care. Candidate lists form from color cuts drawn in multi-band imaging. Later, dispersing the light confirms the redshifts through breaks, lines, and the flat spacings of atomic fingerprints. Photometric guesses become spectroscopic facts. He admires the instruments that make such work possible. A camera that sees in the near-infrared can catch stretched ultraviolet from the first generation of vigorous star formation. A spectrograph with slits or micro-shutters disperses faint light into a comb of wavelengths, prying out emission from ionized oxygen, hydrogen recombination lines, and other traces that report metallicity, temperature, and the density of star-forming regions. A mid-infrared imager opens a portal to dust that glows with the warmth of starlight it has swallowed. Together, these tools turn pale smudges into narratives. The earliest visible cities of stars are not featureless. They carry clumps, bars, hints of rotation, and evidence of winds that push gas into halos. He listens to the numbers that pour from the spectra. Star formation rates implied by ultraviolet luminosity and corrected for dust. Stellar masses inferred from the balance of light across bands and anchored by breaks shaped by aging stars. Metallicity estimates from line ratios that behave like thermometers and barometers for ionized gas. Some early objects exhibit lines so strong that they suggest compact regions where stars are minted with ferocity. Others reveal quiet growth, assembling mass like patient builders laying courses. The diversity surprises. Variety arrives early, as if the recipe for complexity did not require long simmering. He studies the fossil record written into the faint, diffuse glow around galaxies. Surface brightness dims cruelly with distance. Each square arcsecond fades as the fourth power of 1 plus redshift because of expansion and time dilation. Structures that would be obvious if brought near fall below detection when far. Deep fields fight this bias with exposure time and with careful modeling of the sky background. Even so, tails and halos are hard to see. Where a fuzz appears, it may be the signature of outflows that carry metals into the circumgalactic medium. Where absence reigns, it may reflect both youth and the tyranny of dimming. He learns not to mistake invisibility for simplicity. He turns to gravity's own magnifying glass to push farther. A massive cluster between observer and target bends and brightens the light from background galaxies. Long arcs, multiple images, and amplified knots appear in the images of lensing fields. Nature provides the extra gain. With mass maps constrained by the lensing pattern, astronomers reconstruct the unlensed sources, inferring their sizes and star-forming clumps at scales otherwise out of reach. The technique converts a small number of cleverly chosen foreground structures into natural telescopes that rival any mirror humans can launch. The trade is complexity. Lens models demand iteration and fidelity to subtle features. Rewards include seeing individual star-forming regions in a galaxy that breathed when the universe had barely left childhood. He considers another messenger that complements light. Radio arrays hunt for the faint line of neutral hydrogen at a wavelength that redshifts into meter and centimeter bands for the early epochs. Tomographic maps could be made that trace the transition from a fog of neutral gas to a transparent medium carved by the radiation of the first objects. The task is monumental because foregrounds are orders of magnitude brighter, but correlations between radio maps and deep fields promise a pathway. Aligning the catalogue of galaxies with cavities and rims in the hydrogen fog would show how light ate the night. He listens for the story of the first black holes that grew too quickly. In deep fields, tiny yet luminous points appear, whose light is too concentrated to be explained by stars alone. Spectra reveal the broad lines of gas orbiting deep wells. Some of these engines blaze when the universe was a few percent of its current age, implying that black holes reached millions or billions of solar masses in a time that seems too short for calm accretion. Scenario Sarice in response. Direct collapse of dense gas clouds that bypass the star step. Runaway growth, aided by dense feeding environments. Mergers of seeds born from the deaths of very massive stars. Deep fields do not settle the debate, but they anchor it in non-negotiable facts. The engines are there. They shine with a brightness that demands a rapid early path. He examines evidence for the first metals. Lines from oxygen and other elements in high redshift galaxies speak of earlier cycles of star, birth, and death. The earliest objects in view are not wholly pristine. Their gas already carries the ash of massive stars. The very first generation, made of hydrogen and helium alone, remains elusive. The search continues in indirect ways. Extremely strong hydrogen recombination lines with few metal features would suggest low contamination. High-energy gamma bursts from primordial stars turning into black holes would declare their presence. The absence of clear signatures sets limits on how long the universe remained metal-free and how quickly enrichment percolated through halos. He notes a quiet correction that comes from time itself. Light curves of supernovae stretch at high redshift because the ticking of distant clocks is slowed by expansion. 1 plus redshift dilates observed times. In deep monitoring campaigns, this visible stretching becomes both a confirmation of the broader framework and a tool to classify events. The cosmic metronome is not merely a distancing of color and brightness, it is a pacing of events. The far past moves in slow motion when recorded in the present. He feels the poetry and the discipline in that fact. He dwells on the practical truth that even the deepest fields sample a pencil-thin cone. Cosmic variance shadows every conclusion drawn from a narrow view. To defeat it, multiple deep fields in different directions are required, along with wider but shallower surveys to provide context. The strategy mimics an artist who alternates between fine brushwork and broad washes. Detail without context misleads. Context without detail remains bland. Together they produce a faithful scene. He returns to the central surprise that deep fields deliver. The edge of the visible is not a hard line. It is a frontier that recedes as instruments grow more sensitive and as techniques sharpen. Every increment in exposure, every advance in detectors, opens a deeper layer of time. The galaxies seen are smaller, more chaotic, and more prolific in their youth than many suspected. Star formation per unit mass appears intense. Feedback from massive stars sculpts gas quickly. Yet, even in these rough workshops, order takes seed. Disks form, bars appear, and rotation begins to organize chaos. Structure can emerge early if conditions allow, and the conditions did. He ends with a still image held in the mind. A patch of sky so small that a grain of sand held at arm's length would hide it. Within that patch are thousands of galaxies, each a city of billions of stars, each carrying its own weather and history. Their light left when language had not yet been spoken by any mouth, when planets like this one were ideas hidden in chemistry. The edge of the universe, when approached through such a keyhole, proves to be a depth of time rather than a rim of space. He feels the calm that comes from honest seeing. The night is not empty. It is a book that reveals more words each time one leans closer, and the ink at the oldest pages is still legible if the light is gathered long enough and with care. He seeks a cartography written by atoms too shy to shine, and discovers that darkness can be surveyed by a single whispered line. Neutral hydrogen carries an internal clock. When the electron flips its orientation relative to the proton, it emits or absorbs a photon of a very specific energy. In a quiet laboratory, this transition corresponds to a wavelength a little over 21 centimeters. In the sky, that same transition is shifted by expansion into meter-long radio waves that drift like distant surf. Because hydrogen once filled the cosmos almost everywhere, the line becomes a universal tracer. It marks where gas was cold or warm, where it gathered or thinned, where the first lamps of the universe began to bleach the night. He learns the grammar that turns the whisper into a map. The brightness of the signal depends on the spin temperature of hydrogen relative to the background glow. If the spin temperature sits below the background, the gas appears in absorption. If it rises above, the gas glows in emission. Collisions at high density couple the spin to the kinetic temperature of the gas. Later, starlight near a certain resonance mixes the states through a subtle exchange, making the spin follow the warmth of the gas even when collisions weaken. This exchange carries a quiet name born of two researchers. It is a lever by which the first stars announce themselves without being seen directly. Where their light reaches, the background hydrogen shifts its mood from silence to response. He traces the expected journey across time. After the primal glow released the photons that coast through space today, hydrogen settled into a long, cool night. The gas temperature fell faster than the background radiation, so if the spin aligned with the gas, an absorption trough should appear in the sky's radio spectrum. When the first source is lit, they flooded space with ultraviolet that strengthened the coupling and made the absorption deeper. As X-rays from early remnants warmed the gas, the spin temperature climbed, the trough shallowed, and emission could follow. Finally, as young galaxies ionized their surroundings, neutral hydrogen retreated to islands and filaments, and the signal fractured into patches. The line thus offers a chronicle with chapters called Cosmic Dawn and Reionization, written not in light one can see, but in tones one can tune. He listens to the challenge that comes with such promise. The foreground is loud. Our own galaxy hums with synchrotron radiation that is many orders of magnitude brighter than the hydrogen chorus he wants to hear. Human technology clutters the band with leaks and reflections. The ionosphere ripples and refracts. Even the instruments themselves turn honest signals into tricky artifacts when their beams change subtly with frequency. The strategy is to use smoothness as a key. Foregrounds vary gently across frequency, while the cosmic signal carries spectral features. Fitting the smooth part and subtracting it without harming the delicate curve is an art that requires both humility and stubbornness. Arrays built in quiet deserts, elemental antennas spread over baselines from tens of meters to kilometers, and digital backends that sift torrents of data are the tools of this art. He imagines two complementary approaches as two kinds of listening. One is global. A single, well-calibrated antenna samples the entire sky and seeks the faint dip and rise of the averaged signal across frequency. The other is interferometric. Many antennas work together to synthesize a telescope that can image, or at least measure the statistical roughness of the signal across the sky at each frequency. The first promises a simple curve that announces when the universe cooled, warmed, and brightened. The second promises a three-dimensional power spectrum that tells how structure grew and how the light of young sources hollowed out bubbles in the neutral sea. Each approach faces its demons. The global curve can be mimicked by subtle instrumental reflections. The interferometric power can be polluted by a wedge of foreground leakage that presses against the modes most needed to see the undistorted cosmos. Solutions involve meticulous calibration, novel beam designs, careful baseline choices, and mathematical filters that respect both the signal and the imperfections of the instrument. He sees how statistics become pictures. The signal can be decomposed into modes that describe variations across the sky and along the line of sight. Separations in frequency correspond to separations in time because expansion stretches wavelengths continuously. By arranging data into cubes with 2 spatial axes and 1 frequency axis, one can speak of a power spectrum that varies with scale and epoch. Peaks in this spectrum track the sizes of ionized bubbles around early sources and the characteristic lengths over which heating and ultraviolet coupling spread. As the bubbles grow, power shifts from small scales to larger ones. When ionization nears completion, the power fades, leaving behind a quiet intergalactic medium punctuated by knots where neutral gas survives in sheltered pockets. He watches how crosstalk between messengers clarifies the story. The radio maps can be compared with catalogues of distant galaxies that flourish in deep imaging at infrared and optical wavelengths. Where galaxies cluster, the neutral signal should be weaker because those neighborhoods are ionized first. Correlating the two tells whether the chosen galaxies are powerful architects of reionization or mere decorations in a larger arrangement driven by unseen contributors. Cross-correlations with maps of how mass bends background light reveal how the signal relates to the underlying skeleton of gravity. Even the faint curling of ancient microwave polarization, rearranged by intervening structure, can serve as a lensing partner to the hydrogen map. Each pairing turns ambiguity into inference. He pays attention to the physics that enriches the forecast. The intensity of X-rays from early remnants sets how quickly the gas warms, which controls the depth of the early absorption. The abundance of the first small halos sets how fast ultraviolet coupling spreads. The hardness of spectra from young black holes and stellar clusters sculpts the contrast between regions. Redshift space distortions, born from peculiar velocities that add to the Hubble flow, anisotropically stretch and compress patterns along the line of sight, adding a diagnostic of motions to the map of temperatures and ionization. Even exotic possibilities like interactions between ordinary matter and an unseen partner could deepen the absorption by cooling the gas more than expected. Each knob on this control panel moves a feature in the curve or in the power spectrum, and so can be constrained by listening carefully. He considers the reward of first images. A tomographic slice of the sky at a given frequency would show a foam. Black patches where ionized regions erase the neutral signal. Grey filaments where gas remains unlit or underheated. Bright islands where warming or coupling is strong slide through frequency and the foam evolves. Cavities breed, merge, and percolate until the neutral fraction plummets. Such images would be more than postcards. They would be lab notebooks revealing the relative timing of stars and black holes, the efficiency of photon escape from galaxies, and the tug of gravity in assembling the scaffolding that guides all later formation. He returns to the ground truth of instrumentation. Antennas must know their own shapes in frequency and direction, as intimately as a violinist knows the timbre of a favorite instrument. Calibration sources must be stable and traceable. Reflections within cables and between the ground and the feed must be tamed by design and by algorithms. Sites must be radio quiet and stable in climate. Data rates soar, so pipelines must be robust and transparent. Teams must share methods so that independent instruments can confirm one another. Science at this threshold of faintness is communal by necessity. Confidence emerges when different paths that suffer different systematic ailments converge on the same quiet signature. He allows himself a glimpse of what the full cartography will teach. The ages of first coupling, heating, and ionization will be pinned with uncertainty small enough to anchor other histories. The timeline of black hole growth will be narrowed by the imprint of their hard spectra. The biasing of luminous sources relative to the underlying mass will be measured in a new way. Constraints on the smallest halos, invisible to ordinary surveys, will arrive from the statistics of patchiness. Even feedback loops, where early light changes the later formation of stars by heating and photoevaporation, will be sketched as causal chains rather than vague narratives. The map will turn the night between the primordial glow and the first constellations into a documented geography. He ends by standing in a desert at dusk, near a low forest of metal that drinks the radio quiet. The horizon reddens while the first stars wake. The array waits for night to bring the band where hydrogen has hidden its diary. No mirror glints, no domes rotate. Simple dipoles listen. What they may recover is not a picture in the ordinary sense, but a history written in a single shy frequency, repeated across time and bent by expansion into a song. The edge of the universe, approached this way, is a threshold between silence and ignition. He feels the patience of instruments matched to patience in the sky, and the ancient atom becoming a guide that leads the traveller through the unseen rooms of the first mornings. He gathers instruments that do not sing in the same key and learns to make a choir. Some measure brightness, some measure scale, some measure rhythm, and some measure the very bending of time. Together they turn distance from a vague sense into a set of calibrated paths through the dark. He begins with candles whose flames are steady enough to trust. Certain exploding stars peak at nearly the same true luminosity once corrected for how quickly they fade. Their light curves, stretched or sharpened, disclose the wattage within. Compare that intrinsic shine to what arrives and the separation can be solved. A ladder of such candles climbs from the local neighborhood into the deep reaches, each rung cross-checked by nearer rulers so that no single assumption bears too much weight. Out of this ladder comes a record of distance that bends with redshift in a way that tells how the scale of the universe changed. He turns to a second ruler, not made of light from a single source, but carved into the distribution of many. Before the Great Clearing, pressure waves rippled through the plasma, running outward until the fog thinned. The distance those waves traveled before arrest became a preferred separation. Later, when gas cooled and galaxies gathered, the imprint remained as a gentle excess in the likelihood that pairs of galaxies appear at that scale. In a survey of millions of galaxies, the imprint emerges as a small bump in a graph of pair separations. This is a ruler laid down by a drum long silent. It does not rely on any single galaxy being understood. It averages over multitudes and so resists the quirks of individuals. Measure the angular size of this preferred scale at various redshifts, and the expansion history becomes a curve accessible to geometry. He adds a third voice that uses space itself as a lens. A massive cluster between an observer and a background source bends light into arcs and multiple images. Each image takes a slightly different path and spends a different amount of time climbing in and out of gravitational potential wells. When the background source varies, those variations arrive with delays that can be measured. The geometry of the lens and the timing together yield a distance scale. No single clock is needed, except the variability of the source itself. Quasars, with their restless hearts, serve well. In this method, time is transformed into distance through the mediation of curvature. The elegance is in the relative measurement. Even if the source is poorly known, the pattern of delays carries the fingerprints of the cosmic yardstick. He listens for a new kind of messenger whose language is strain rather than brightness. Two compact stars spiral inward, radiating gravitational waves that rise in pitch and amplitude until a sudden merger. The waveform is predictable from the physics of orbits and relativity. From it, one can infer the absolute scale of the event. Such a source is a siren that broadcasts its distance without needing a ladder of calibrations. If the glow of a counterpart is found, its redshift can be measured and a point plotted on the distance redshift plane, with minimal mediation. Even without a counterpart, statistical associations with likely host galaxies can provide constraints. A network of such sirens would be a metronome for the expansion history, independent of assumptions that govern light. He considers megamasers that orbit close to the cores of certain active galaxies. Clouds of water vapor act as natural lasers at radio wavelengths, circling a central mass in nearly Keplerian fashion. By mapping their velocities and angular positions with very long baseline interferometry, one obtains both the physical scale of the orbit and its apparent size on the sky. The ratio is distance, direct, and geometric. Few such systems are known, but each one is a gift, a yardstick placed by nature in a regime where gravity is sharp and geometry is clear. These maser disks act like surveyor's chains laid around the throats of galactic engines, setting a baseline that is independent of candles or rulers etched in galaxy pairs. He attends to cosmic chronometers that count time written into the aging of stars, the spectral fingerprints of a population shift as its stars grow older, and with careful modeling, The difference in age between galaxies at nearby redshifts can be estimated. That age difference divided by the redshift difference gives the rate at which redshift changes with time, which in turn is directly related to the expansion rate. It is a subtle method, sensitive to the recipes used to model stellar populations, but it measures a derivative that is not otherwise easily reached. Where distances integrate the history, chronometers sample its slope. Together they provide both the shape of the curve and how steeply it climbs. He notes that each method bears its own systematics. Candles demand corrections for dust and for the subtle dependence of their brightness on environment and metallicity. Rulers stamped into galaxy distributions require faithful modeling of how bias and redshift space distortions decorate the underlying mass. Lenses must be mapped with care, accounting for mass along the line of sight and for the way light threads clumpy potentials. Sirens rely on waveform modeling and on the fidelity of detectors that must pick out strains as small as parts in 1,000 trillion. Masers require long campaigns and precise baselines. Chronometers depend on stellar libraries and on understanding how chemical abundance alters spectra. None of these flaws are fatal. Each can be characterized, simulated, and folded into uncertainties that shrink as data accumulate. He watches how cross-calibration turns a set of partial truths into a resilient picture. Where candles and rulers overlap in redshift, their distances must agree within uncertainties if both are faithful. Where lensing delays provide a measurement of the Hubble constant, it can be compared with the value inferred from the early universe through the imprint on the microwave sky combined with a selected model. Sirens are particularly valuable because they sidestep the distance ladder. If their distances confirm or challenge existing values, they can arbitrate quietly between rival interpretations. A web of comparisons reveals tensions when they exist. Such tensions are not embarrassments. They are signposts. They either point to unrecognized systematics in one method or to new physics that alters the path from early to late. He imagines a universe scored like music on staves of redshift. At low redshift, nearby candles and masers speak clearly. At intermediate redshift, the galaxy ruler adds notes in a steady rhythm. At high redshift, deep candles and the relic drumbeat fix points that bridge toward the ancient light. Lenses add grace notes wherever variability cooperates, turning echoes in time into lengths along the staff. Sirens cut through with pure tone when mergers are caught with both waves and light. Read together, the composition is a history of stretching, a record of when slowing gave way to accelerating and by how much. The melody is fragile if any instrument plays alone, but when the orchestra works in concert, the tune is unmistakable. He takes a quiet detour into the geometry of errors. Distances carry statistical scatter from measurement and cosmic variance. They also carry biases that can creep in through selection effects. Brighter objects are easier to find, which can skew samples unless corrected. Lensing by intervening mass can magnify or demagnify candles, nudging brightness distributions. Peculiar velocities add noise at low redshift, where local flows tug galaxies away from the smooth expansion. Each effect can be modeled. Simulations create mock catalogues that reveal how a survey would distort truth. Comparing these mocks with data allows corrections that are honest rather than hopeful. The act of measuring the edge is as much about tenderness with uncertainties as it is about daring with depth. He respects the role of time in every method. Candles require long monitoring to catch the rise and fall of light. Rulers demand vast surveys that take years to complete. Lenses need patient watching to register echoes. Sirens call when rare mergers happen and observatories must be ready to triangulate. Masers drift in and out of detectability as conditions in the disk change. Chronometers need deep, clean spectra that can only be gathered with long integrations. The calendar of the sky is a collaborator that cannot be rushed. The reward for respect is a map that does not wobble when new data arrive. He sketches a future where these tools refine the outline of fate. If the equation of state of the agent behind acceleration deviates even slightly from a constant, the curve of distance with redshift will bear the deviation. Candles and rulers at higher redshift will feel it first. Sirens will sample different epochs as detectors reach deeper. Lenses will accumulate and their delays will stack into a firm constant of expansion. Masers will add geometric anchors. Chronometers will measure the slope of Hubble as a function of time with new poise. Each method will be sharpened by new instruments. Wider spectroscopic surveys, deeper imaging in the infrared, more sensitive wave detectors, radio baselines that span continents. The choir will grow and the harmony will tighten. He ends with a scene of sound where there is no sound. Imagine standing in a hall with pillars of different materials. A soft hum passes through, and each pillar resonates at its own frequency. By listening to how the notes add, one can infer the shape of the hall. In cosmology, candles, rulers, lenses, sirens, masers, and chronometers are those pillars. Their resonances are distance, time delay, angular scale, strain, orbital geometry, and spectral aging. The hum is the expansion itself. By attending to the combined music, the shape of the hall is recovered. The edge becomes a curve traced in parameter space rather than a wall to touch. And the surprise is how human patience and a handful of physical regularities can recover a structure so vast that no traveler could ever traverse it. He feels the calm satisfaction that arrives when many imperfect truths agree and the horizon of understanding moves a little farther away. He enters a room filled with artificial skies, where gravity is written in code, and time is a slider the hand can move. A cosmological simulation does not build a miniature universe on a table. It evolves equations on a lattice that floats in memory, a cube of space populated by particles that stand in for clumps of matter. The cube has no walls. Its faces are stitched to each other, so that anything leaving one side returns from the opposite side, as if the cube tiled all directions. This trick is not a fantasy of repetition. It is a way to honor homogeneity while avoiding an edge that would poison the calculation with reflections. Within the cube, gravity gathers, expands, and shapes filaments and knots. The artificial sky grows a web that resembles the one traced by galaxies when surveyed with light. He watches the first step, which is to draw seed ripples. These ripples come from a random field specified by a power spectrum that sets how much variation lives at each scale. A phase is drawn for every mode. The phases matter because they choreograph how peaks and valleys line up. Displace particles along gradients of this field to mimic how matter would drift in the earliest linear regime. Step forward in time with small increments. Each increment is a calculation of forces between particles or between particles and a potential defined on a mesh, followed by an update of positions and velocities. The dance is a compromise between accuracy and speed. Too small a step wastes resource. Too large a step lets fast orbits blur into artifacts. He studies how resolution decides what can be believed. A simulation with billions of particles can capture the birth of galaxy-sized halos and the filaments that feed them. It cannot resolve the lives of stars inside those halos. Zoom techniques push farther. Pick a region of interest in a coarse run and rerun it at higher resolution while keeping the rest of the universe coarser to provide tidal context. Now individual halos host subhalos, and their orbits can be followed through mergers and tides. Yet even this zoom stops short of the true complexity of a real interstellar medium. Subgrid models appear to carry the story through the gap between what can be computed and what must be represented. He turns to hydrodynamics, the other half of the craft. Gas is not a set of collisionless points. It carries pressure, shocks, turbulence, and cooling that turns energy into radiation and allows collapse. Two broad families of methods are common. One represents gas with particles that carry density and temperature and communicate with neighbors through smoothed kernels. The other lays the gas on a mesh that can refine in regions of interest, capturing shocks with Riemann solvers. Each approach has strengths. Particles follow flows without advection error. Meshes capture fluid instabilities with crisp accuracy. Hybrid schemes mix ideas to harvest the advantages of both. Regardless of method, gas cools, condenses, and forms stars according to recipes that are tuned against real galaxies. He examines feedback, the complicated exchange that prevents every clump of gas from collapsing into stars too quickly. Massive stars inject energy and momentum through winds and supernovae. Black holes at galactic centers heat and stir gas through jets and radiation. These events happen on scales too small to resolve directly in a cosmological box. They are modeled as subgrid prescriptions that kick gas, heat it, or change its state in bursts or in continuous dribbles. The parameters of these prescriptions are not decorations. They control the slope of galaxy mass functions, the sizes of disks, the quenched fraction in massive halos, and the metal content of circumgalactic reservoirs. Calibration is a negotiation. Too little feedback yields galaxies that are too massive and too blue. Too much feedback erases disks and starves halos that should be healthy. He reads the outputs like an atlas. Halos are found by friends of friends algorithms or by density peaks that enclose regions with a defined contrast relative to the background. Trees are built that connect halos across time, revealing lineages that merge, split, and end. Gas flows are traced with tracer particles or by following cell histories. Star formation histories are compiled for each object. Synthetic images are made by sprinkling stars with spectral templates, reddening them with dust models, and projecting through the box at chosen angles. Lensing maps are computed by integrating the projected mass. The web between halos appears as filaments that align spins and anisotropically feed growth. Voids open like lungs between walls. The map is familiar and strange at once, a rehearsal that becomes an explanation when compared with surveys. He recognizes limits that honesty must keep near. Periodic boundaries simplify the universe, but hide the largest modes that might influence tides. Boxes must be large enough to capture the variance of rare massive structures and small enough to resolve the dwarf halos that seed complexity. Convergence tests ask whether increasing resolution changes results in unacceptable ways. True convergence is rare for quantities that depend on subgrid physics. The aim becomes practical. Identify stable predictions, understand where freedom in the prescriptions leads to degeneracy, and isolate diagnostics in data that can break the tie. He watches small-scale crises sharpen methods. Cold, collisionless matter creates inner density cusps in halos, while some dwarf galaxies prefer cores in their dynamics. Feedback can puff gas and loosen dark matter enough to flatten a cusp if the bursts are timed and strong. Alternative matter models replace cold with warm or self-interacting species, changing halo structure and sub-halo survival. Simulations are testbeds for these ideas. Change only one ingredient, hold the rest, and measure what differs. Match to rotation curves, to satellite counts, to lensing substructure. The box becomes a laboratory where hypotheses are not just described but stressed. He sees machine learning step in as an interpreter and an emulator. Neural networks trained on high-fidelity runs can predict how halos populate with galaxies without running new heavy calculations. Surrogate models translate fast course runs into approximations of slow, detailed ones. Generative networks paint gas and stars on dark matter scaffolds. Caution is needed. A network can learn a bias as easily as a truth. Validation against independent runs and against real data keeps optimism disciplined. The reward is speed. Parameter spaces that would take lifetimes to explore become navigable, and inference from data can sample priors with honesty. He follows a different path into the box where radiation is not an afterthought. Light from stars and black holes travels, ionizes gas, and heats it in ways that feed back on formation. Radiative transfer is costly because it couples many scales and directions. Shortcuts abound. Moments of the radiation field can be advanced with closures that approximate angular structure. Rays can be cast in limited numbers and split adaptively. Ionization fronts can be tracked with simplified chemistry. Each choice balances accuracy and expense. When radiation is included with care, the timing and topology of the last neutral gas change in ways that connect directly to maps in radio and to the faint damping of small-scale power in ancient light. He pays attention to the ethics of matching data. A simulation can be tuned to look right if enough knobs are turned. The temptation is to declare victory when images please the eye. Discipline resists that ease. One demands simultaneous agreement with many statistics that are not obviously linked by the prescriptions. Stellar mass functions, color distributions, gas fractions, metallicity relations, sizes, kinematics, and lensing signals must fit within a single run. Where they do not, the failure is a map of ignorance, not an embarrassment. The craft then divides. Some work pushes resolution to capture more physics directly. Some work refines subgrid models with insights from targeted small simulations of interstellar clouds and black hole accretion flows. Some work improves numerics to reduce artificial diffusion or unphysical two-body heating. He contemplates the idea of an initial condition that is not perfectly Gaussian. Tiny departures imprint subtle, non-random patterns in the phases of the seed field. Those patterns can change the abundance of the rarest halos and the bias by which galaxies trace mass. The box can plant such seeds and measure the effect on the growth of structure, then predict signatures in surveys that track the most massive clusters or the distribution of voids. If surveys find the predicted fingerprints, the inference points back to physics in the earliest instance. The loop closes between a statistical tweak at the start and a measured pattern in the late web. He glances at human time. A single flagship run can drink months of supercomputing, writing petabytes of snapshots that must be analyzed with software that can parallelize across memory hierarchies. Communities form around these artifacts, sharing catalogs and mock skies. Observers use the mocks to plan surveys and to estimate how selection will bias conclusions. The exchange narrows the gap between coded universes and the one that throws photons across meters of vacuum to glass and silicon. Collaboration smooths rough edges. The synthetic skies become rehearsal stages where methods are tested against dangers that would otherwise surprise. He closes his notebook as the artificial cube continues to evolve on machines far away. The lesson is quiet. Simulations do not replace the sky. They are companions that predict, explain, and warn. Within a periodic box with no rim, structure grows without asking for a boundary. Filaments thread across memory. Halos merge and rest. Stars switch on and die. Black holes wake and sleep. Gas cools and warms. Winds blow and stall. Out of the code emerges a language that translates between equations and maps. The edge becomes not a place, but a set of boundary conditions chosen for clarity. In that choice, insight thrives. He leaves the room with respect for a craft that turns numbers into weather on a scale no wind can touch, and for a patient practice that tests ideas by letting them run until they either build a believable sky or unravel in their own logic. He stands at a riverside of light and learns that limits can be kind. The water is not water. It is time shaped into distance, flowing in one direction yet reflecting many shores. The far bank cannot be reached by any bridge of matter, yet the sound of that bank travels across the current as faint ripples of photons. He listens and hears not refusal but cadence. The cadence says that knowing has a tempo. It says that surprise is conserved the way energy is conserved. Every answer spends a little of it, and every frontier mints more. The river keeps its level by moving the sandbar where questions break. He tries to name the feeling that arrives when a horizon is understood, not triumph. The sky is too patient for that, not defeat. The sky is too generous. It is something like relief. If boundaries did not exist, experience would be a flood with no banks, and meaning would dissolve into undifferentiated water. With boundaries, currents can be traced, and navigation becomes possible. A person is smaller than the river, and therefore can read it. Humility here is not a punishment. It is a scale on which gratitude can be weighed honestly. He observes how the mind changes when it meets a world that refuses simple edges. On land, a cliff is definitive. Step past, and the story ends. In the heavens, an edge is a gradient between what can converse and what will remain private. Privacy at this scale is not a moral fence. It is a property of motion and time. He recognizes dignity in that privacy. Distant regions are not scenes arranged for an audience. They are their own events, complete without the witness he offers. Knowing this deepens his respect for the part he can learn. The map gains weight when he accepts that it will always be incomplete. He rests in the idea that a limit is a kind of promise. If the farthest sight today is defined by time, tomorrow the circle will widen. Chance will deliver new messengers from the edge of patience. The messages will announce their age and their origin, and he will hear them with instruments that are themselves stories of patience compacted into glass, silicon, and code. A horizon that moves outward does not retreat from curiosity. It invites curiosity to keep time with it, to revisit, to compare, to notice that the same portion of sky is a different page each decade because more lines have arrived. He lets the scale of personal life speak quietly alongside the scale of galaxies. He will not see many winters compared with the number of winters the universe will keep. He will not taste many Novembers compared with the calendar that measures the thinning of backgrounds and the slow retreat of communicable shores. Yet his span is not irrelevant. It is the exact interval during which a certain set of instruments existed, a certain archive was kept, a certain culture learned to read faint signals without confusing them for wishes. He is part of the window through which one moment of the sky is documented. That participation is enough. It gives a life the outline of service rather than appetite. He notices that awe behaves like light in a clear medium. It fills available volume without needing to be forced. Remove noise, and it appears. Introduce patience, and it brightens. Focus it with careful lenses, and it becomes coherent. The focus can be scientific, but the feeling is older than any discipline. People have always stood under a sky and felt a pressure of meaning that cannot be used up. Science gives that feeling a grammar. The grammar does not reduce the feeling, it keeps it from being cheap. When measurements speak, the result is not a loss of mystery, but a finer quality of wonder, one that can survive daylight and repeated questioning. He thinks about the temptation to turn edges into metaphysics and holds it at a distance that is respectful but firm. The temptation arises because limits suggest beyonds, and beyonds attract legends. He allows himself a different approach. He holds the beyond as a symbol that permits a life to be honest. The symbol says that not everything will be known, even in principle. This is not a reason to retreat. It is a reason to refine pursuit. A finite speed of light is a curb on arrogance. A horizon written into the shape of time is a brace that keeps the tower of speculation from listing into fantasy. With braces in place, the tower can be higher. He draws a line between noise and silence. Noise is interference that hides a signal. Silence is the absence of the signal because the world has not supplied it or cannot supply it to him. The first can be corrected with better instruments and more careful calibration. The second deserves acceptance with a clear heart. He likes that distinction. It keeps frustration from turning into bitterness. It keeps waiting from turning into impatience. It also helps him see that many of his own limits are noise masquerading as silence. He can fix those. The true silences remain, and they are beautiful. He lingers on the quiet fact that edges, properly understood, are relational. A horizon is not an object lying in space. It is an arrangement between an observer, the history of expansion, and the speed at which influence travels. The arrangement changes with position and time, but is globally consistent. He is soothed by how this removes the anxiety of needing to find a rim and replaces it with the craft of learning to situate himself honestly. Where am I in relation to the light that is arriving? What can I hear today? What can I send? How does the future edit these answers? The questions are modest, yet they open the whole room. He takes pleasure in the discipline of comparing meanings for the same word. Edge as horizon of sight. Edge as boundary of influence. Edge as contour of geometry. Edge as convenience in a simulation. Edge as limit of current instruments that tomorrow will not deserve the name. Sorting meanings is not pedantry. It is mercy for the mind. Confusion exhausts and distorts. Clarity preserves energy for the long work. The long work is not a sprint toward a final explanation. It is a method of living with questions and making them fertile. He wonders what kindness a person can take from a cosmos that will one day dilute familiar landmarks into absence. The kindness is in the recognition that impermanence does not cheapen value. It sets value. The stars that will fade give there now a taste that permanence cannot provide. The edge that approaches gives attention a color it would otherwise lack. A message that can be sent today to a reachable neighbor has a small urgency that ennobles the act. He thinks of archives, of careful writing, of passing on methods more than conclusions. Conclusions age, methods travel well. He imagines teaching a child to look up. The lesson would not be statistics or equations. It would be a posture. Stand on a night field. Let your eyes adapt. Let your mind quiet. Do not hurry toward a fact. Let the field fill with dimness until dimness turns out to be structured. Then speak a little about patience and about how knowing follows rules that are not punitive. Speak of light taking time and of the kindness of limits that keep us from pretending we are bigger than we are. The lesson would end not with a claim, but with an invitation to keep the posture alive. He chooses one last image to carry away. A horizon at sea is a line that depends on the height of the eye. If one climbs the mast, the circle grows. In the sky, the mast is time and craft. Time raises the eye because more light arrives. Craft raises the eye because instruments learn to gather faintness and sort signal from fog. The circle grows. The circle will always grow for as long as there are eyes to lift, and for as long as the world remains hospitable to the act of looking. That growth is enough. A universe that refuses to end cleanly gives a different gift. It permits endless refinement. He lowers his gaze and does not feel smaller. He feels placed. The edge is not a cliff that writes a final sentence. It is a soft geography that shapes the paragraphs of experience. It lets patience be powerful. It turns clarity into tenderness. It makes the present into a well-laid table where distant light is bread, and the finite speed that carried it is the grace spoken before eating. He accepts the meal and the blessing. He leaves the field, knowing that what he carries home is not everything, and that everything is not required. Night thins like ink washed once and left to dry. He crosses a lawn of dew while constellations unthread into the first blue. A bird makes a single note and stops, as if testing the air for permission. There is no hurry in him. The sky has cured him of that. He walks with the slow cadence of someone who has learned the size of a second by measuring it against the patience of stars. He remembers the feel of very old light on the eyes, not as heat, but as a hush. In that hush, fear has little to grip. The world is larger than his plans and kinder than his anxieties guessed. Limits make a cradle rather than a cage. Horizons are invitations written in the grammar of time. He turns the key of this thought and the door opens onto a room that contains his day. Water ticks in a gutter, somewhere a dog sighs. A window emits a rectangle of gold, then goes dim. He imagines the line between what can be said and what must remain silence, not as a razor, but as a soft edge where language hands off to listening. The handoff is clean tonight. He accepts what cannot arrive and tends what has. He promises to keep the instruments honest, to keep the archives generous, to keep the questions lit but not inflamed. Dawn lifts. The horizon of sight shrinks to weather and work. That is not loss. It is the next rightful scale. He pockets the night like a folded letter and carries it into errands, into conversations, into small decisions that add up to a life. When evening returns, the letter will unfold, and the same words will read differently because time has moved. That is the gift of edges. They reshape the same truth without exhausting it. He smiles and steps inside, leaving the door a little open for light to follow. End of script. Sweet dreams.